March 13th, 1918, 9 a.m. Eastern Standard Time. The cargo piers at Curtis Bay, Baltimore, stood empty and silent. Along the wharves where the USS Cyclops was expected to dock, stevedores waited with equipment prepared to unload 10,800 tons of manganese ore. Harbour pilots scanned the entrance to the Patapsco River for the distinctive silhouette of the Navy collier. The ship's berth remained vacant. The USS Cyclops had departed Barbados 9 days earlier, on March 4th at 2 p.m, bound for Baltimore with a full complement of crew and passengers. The voyage was calculated to require approximately 7 to 8 days under normal conditions, placing the expected arrival between March 11th and March 13th. Naval operations at Curtis Bay had scheduled dock space and unloading crews based on the earlier estimate. When March 13th arrived with no sign of the vessel, port officials initially attributed the delay to mechanical difficulties or adverse weather conditions that might have slowed the ship's progress. By noon on March 13th, concern among harbour authorities had escalated from routine impatience to active worry. The USS Cyclops carried not only 236 enlisted sailors and 15 officers, but also 58 civilian passengers, including American Consul General Alfred Gottschalk and his family. The total count of 309 people represented one of the largest complements aboard any naval auxiliary vessel operating in the Atlantic during the spring of 1918. More significantly, the manganese ore cargo in the ship's holds was critical to steel production for the war effort, and its non-arrival disrupted manufacturing schedules at plants throughout the mid-Atlantic region. Communication procedures in 1918 required naval vessels to maintain radio contact with shore stations at regular intervals, particularly when approaching major ports. The USS Cyclops was equipped with standard wireless telegraph equipment capable of transmitting and receiving signals at ranges exceeding 100 nautical miles under favourable atmospheric conditions. Ships approaching Baltimore typically made initial contact with shore stations when passing Cape Hatteras, approximately 400 miles south of the Chesapeake Bay entrance. No such transmission had been received from the Cyclops. Port Captain Howard Reed of the Baltimore Harbor Authority contacted the Navy Department in Washington on the afternoon of March 13th to report the vessel's failure to arrive. Reed's message, logged at 2:30 p.m, noted that the USS Cyclops was now more than 48 hours overdue based on the latest estimated arrival calculation. The Navy Department's response indicated that no communication had been received from the ship since her departure from Barbados on March 4th. This gap of 9 days without any contact represented a serious deviation from normal operating procedures for vessels on this route. The Navy Department's initial assessment treated the situation as a probable mechanical breakdown or navigation error rather than a maritime disaster. Colliers operating between South American ports and the United States frequently experienced engine troubles, particularly older vessels like the USS Cyclops that had been in continuous service since 1910. The department's communication to Baltimore port authorities suggested that the ship might have diverted to another port along the Atlantic coast to effect repairs, or might have reduced speed significantly due to mechanical limitations. Officials authorized a standard inquiry protocol, directing naval stations and Coast Guard facilities from Florida to Maine to report any sightings or communications involving the missing vessel. By March 15th, when the USS Cyclops had been officially overdue for more than 72 hours, the Navy Department's assessment shifted from mechanical delay to possible maritime casualty. The Atlantic Coast Inquiry had produced no reported sightings of the vessel. Weather analysis for the period between March 4th and March 13th showed generally favourable conditions along the standard route from Barbados to Baltimore, with no severe storms or unusual atmospheric disturbances documented. The absence of both the ship and any explanation for her delay elevated concern to the level of formal investigation. The historical context of the USS Cyclops' disappearance occurred during a period of intense German submarine activity in the Atlantic Ocean. The spring of 1918 marked the final phase of unrestricted submarine warfare, with German U-boats operating aggressively against Allied and neutral shipping. American naval vessels were considered legitimate military targets, and several US Navy ships had been sunk by torpedo attack during the previous months. The possibility that the USS Cyclops had been attacked and sunk by a German submarine became an immediate consideration in the Navy Department's analysis of the situation. However, German submarine attacks typically left evidence of their occurrence. Torpedoed ships often managed to transmit distress signals before sinking, allowing rescue vessels to reach survivors or recover bodies and debris. The complete absence of any communication from the USS Cyclops suggested either a catastrophic event that prevented the crew from sending distress signals, or circumstances that left the ship unable to transmit for reasons unrelated to enemy action. The Navy's submarine tracking intelligence, derived from radio direction finding stations along the coast, had detected no U-boat activity in the western Atlantic during early March 1918. The nearest documented German submarine operation had occurred more than 800 miles east of the USS Cyclops' projected route. On March 16, 1918, the Navy Department formally classified the USS Cyclops as missing and initiated a comprehensive search operation. The classification marked the transition from administrative inquiry to active rescue and recovery efforts. Naval vessels operating in the Atlantic were ordered to divert from their assigned missions to search designated areas along the ship's probable route. The search zone extended from Barbados northward through the Caribbean Sea, along the eastern seaboard to Cape Hatteras, and up the mid-Atlantic coast to the Chesapeake Bay entrance. The search assets deployed represented one of the largest peacetime maritime rescue operations in US Navy history. At least 12 naval vessels were assigned to search duties, including destroyers, patrol craft, and auxiliary ships equipped for rescue operations. Coast Guard cutters joined the effort, concentrating on coastal waters and approaches to major ports where the USS Cyclops might have sought emergency refuge. The search pattern was designed to cover not only the standard navigation route, but also alternative courses the ship might have taken if experiencing mechanical difficulties or attempting to avoid perceived threats. Despite the scale and intensity of the search operation, which continued for more than 3 weeks, no trace of the USS Cyclops was discovered. Search vessels reported no wreckage, no debris fields, no oil slicks, no lifeboats, and no bodies. The complete absence of physical evidence distinguished this disappearance from typical maritime casualties. Ships that sink due to collision, structural failure, or weather damage typically leave extensive debris that surfaces and drifts with prevailing currents. The USS Cyclops, with her displacement of 19,360 tons and length of 542 feet, represented a massive structure that should have produced a substantial debris field if she'd broken apart on the surface. The families of the 309 people aboard the USS Cyclops began receiving official notification of the ship's missing status during the final week of March 1918. The Navy Department's communications to next of kin followed standard procedures for missing vessels, indicating that the ship had failed to arrive at her destination and that search operations were underway. The language of these notifications reflected the uncertain status of the situation, avoiding definitive statements about the fate of the crew and passengers, while acknowledging the serious nature of the circumstances. Among those awaiting news was the family of Captain George W. Worley, the ship's commanding officer, who lived in Baltimore. Worley had commanded the USS Cyclops since May 1912 and had accumulated extensive experience operating colliers in Atlantic waters. His family expected him to return home when the ship docked at Curtis Bay, and the failure of the vessel to arrive had created immediate alarm among those who knew the captain's meticulous attention to communication procedures. Worley's reputation as a reliable, if occasionally eccentric commander made his silence particularly disturbing to those familiar with his operational habits. The passenger list for the USS Cyclops' final voyage included multiple families travelling together, multiplying the tragedy's impact on specific communities. Consul General Gottschalk had been returning to the United States with his wife and 2 daughters after completing his diplomatic assignment in Rio de Janeiro. Several business executives who had been working in Brazil's mining industry were aboard, along with their families. The crew included sailors from ports throughout the eastern United States, many of whom had wives and children who now faced uncertain futures. By April 1st, 1918, nearly 4 weeks after the USS Cyclops had departed Barbados, the Navy Department acknowledged that hope for finding survivors had effectively ended. The search operation was formally suspended, though naval vessels continued to monitor for any reports of wreckage or debris that might provide clues about the ship's fate. The classification of the vessel shifted from missing to presumed lost, though no official declaration of death would be made for the crew and passengers until sufficient time had passed to satisfy legal requirements. The financial implications of the USS Cyclops' loss extended beyond the humanitarian tragedy. The ship itself represented an investment of more than $1 million in 1910 construction costs, with additional expenditures for maintenance and upgrades during her 8 years of service. The manganese ore cargo, valued at several $100,000, was critical, strategic material that would need to be replaced from other sources. Insurance claims and compensation for families of the lost crew and passengers created additional financial obligations for the Navy Department and the federal government. The scale of the loss made the USS Cyclops' disappearance the largest non-combat casualty in United States Navy history. No previous peacetime incident had resulted in the loss of an entire ship, and all aboard without any survivors or physical evidence of the disaster. The disappearance exceeded the casualties of many combat engagements and created a maritime mystery that would persist for decades. Naval historians and maritime investigators would examine the case repeatedly, attempting to determine what circumstances could cause a 260-ton steel vessel to vanish without leaving any trace on the ocean's surface. The official Navy Department announcement of the USS Cyclops' loss, published in newspapers on April 2, 1918, provided minimal details about the circumstances. The announcement stated that the vessel had departed Barbados on March 4th bound for Baltimore and had failed to arrive. Search operations had discovered no evidence of the ship's fate. The announcement listed the total complement as 309 officers, crew, and passengers. The announcement concluded with the standard formula that the ship was presumed lost at sea with all hands, though the specific cause of the loss could not be determined based on available evidence. The USS Cyclops had been scheduled to depart Baltimore on a return voyage to South America within days of her expected arrival on March 13th. The cancellation of this voyage and the need to assign replacement vessels to the ore transport mission disrupted Navy logistics and commercial shipping schedules throughout the spring of 1918. The loss of the ship created a gap in the Navy's auxiliary fleet that required reallocation of other colliers and cargo vessels to maintain the flow of strategic materials from South American sources to American industrial facilities. On April 15, 1918, the Navy Department formally declared that the USS Cyclops and all aboard were considered lost. The declaration carried legal implications for compensation claims and insurance settlements, though many families would wait years for final resolution of their cases. The official count remained unchanged from the initial reports filed on March 13th, when the ship failed to arrive in Baltimore. The vessel had departed Barbados, carrying 236 enlisted sailors, 15 commissioned officers, and 58 civilian passengers. Of the 309 people who had been aboard when the ship left Barbados on March 4, 1918, not a single individual survived. No bodies were recovered, no wreckage was found, no distress signal was ever received. The USS Cyclops had simply vanished from the Atlantic Ocean, leaving behind only questions and the empty berth at Curtis Bay, where she should have docked. The USS Cyclops, designated AC-4, was a Proteus-class collier measuring 542 feet in length, with a beam of 65 feet, and displacing 19 through 360 tons when fully loaded. Her construction at the William Cramp and Sons shipyard in Philadelphia represented a significant investment in naval auxiliary capability, with the vessel designed to transport coal and other bulk cargo in support of fleet operations. The ship's keel was laid on June 15, 1909, and construction proceeded according to standard procedures for colliers of this class. The vessel was launched on May 7, 1910, and commissioned into active service on November 7, 1910, at a total construction cost exceeding $1 million. The ship's power plant consisted of twin vertical triple expansion steam engines, each driving a separate propeller shaft. The port and starboard engines were designed to operate independently, allowing the vessel to maintain propulsion even if one engine failed. Each engine developed approximately 4,500 indicated horsepower, providing a combined output of 9,000 horsepower under optimal conditions. The engines drew steam from 4 coal-fired boilers located in the forward section of the engineering spaces. This propulsion system could drive the vessel at a maximum speed of 15 knots in calm seas, though typical cruising speed for economical fuel consumption was calculated at 10 to 12 knots. The USS Cyclops was designed as part of the Navy Collier Fleet, a specialized group of cargo vessels tasked with transporting coal from supply bases to warships at sea. The collier function required specific structural features that distinguished these vessels from standard cargo ships. The cargo hold was divided into multiple compartments to prevent shifting of loose coal during transit. Loading and unloading equipment included 4 large coal handling booms capable of transferring cargo at rates exceeding 100 tons per hour. The ship's deck was reinforced to support the weight of coal handling machinery and the concentrated loads imposed during cargo operations. The Proteus-class design incorporated several features intended to maximize cargo capacity while maintaining the structural integrity necessary for ocean service. The hull form was optimized for volume rather than speed, with relatively bluff lines forward and aft that created internal space for cargo storage. The single smokestack was positioned amidships to allow maximum hold volume both forward and aft of the engineering spaces. The bridge structure and crew accommodations were concentrated in a superstructure that rose above the cargo deck, providing clear visibility for navigation while leaving deck space available for cargo handling operations. The vessel's crew complement under normal operations consisted of 236 enlisted personnel and 15 commissioned officers. The enlisted ranks included deck department sailors, responsible for navigation and cargo handling, engineering department personnel, who maintained the propulsion and auxiliary machinery, and stewards department staff who managed food service and berthing spaces. The officer complement included the commanding officer, executive officer, navigator, chief engineer, and department heads for deck, engineering, and supply functions. Additional officers served as watchstanders and supervised specific operational areas. The cargo capacity of the USS Cyclops was rated at 10,500 tons of coal under standard loading conditions. The hold volume of approximately 450,000 cubic feet allowed the ship to carry sufficient coal to refuel multiple warships during extended deployments. The internal configuration included 5 main cargo holds separated by watertight bulkheads. Each hold was equipped with ventilation systems to prevent the accumulation of coal gas and to manage temperature during long voyages. The design specifications required that cargo be distributed evenly throughout the holds to maintain proper trim and stability. However, the conversion of the USS Cyclops from coal transport to ore-carrying service created conditions that challenged the original design parameters. Coal has a specific gravity of approximately 0.8 to 1.0, depending on the type and moisture content. Manganese ore, by contrast, has a specific gravity of approximately 3.8, making it nearly 4 times heavier than an equivalent volume of coal. When the USS Cyclops loaded 10,800 tons of manganese ore in Rio de Janeiro during February 1918, the cargo occupied only a fraction of the available hold volume, but represented a weight load exceeding the ship's original design specifications. The structural implications of carrying dense ore cargo instead of coal involved multiple engineering considerations. The bottom plating of the cargo holds was designed to support the distributed weight of loose coal, which would naturally level itself within the hold space. Dense ore cargo created concentrated weight loads on the bottom plating and internal framing members. The reduced volume of ore cargo meant that the weight was confined to the lower portions of the holds, lowering the ship's centre of gravity and reducing the available freeboard. These factors affected the vessel's stability characteristics and seakeeping behaviour in ways that were not fully understood in 1918. The ship's structural survey, conducted at Norfolk Navy Yard in 1917, had revealed concerning conditions in several critical areas. Inspectors documented cracks in the engine bed castings that supported both the port and starboard propulsion engines. The cracks appeared in the mounting structures that transferred engine vibration and thrust loads to the hull framing. Engineering analysis indicated that the cracks had developed due to cyclic stress from engine operation and hull flexing in seaway conditions. The survey report recommended repairs to reinforce the cracked castings, but the work was deferred due to operational requirements and limited shipyard capacity during wartime. The structural condition of the keel and bottom framing also showed signs of stress that concerned Navy inspectors. The USS Cyclops was built using riveted construction techniques that were standard for ships of this era. The hull plates were joined by overlapping seams, secured with multiple rows of rivets. Over time, riveted seams could develop leaks as rivets loosened due to working loads and corrosion. Survey reports from 1916 and 1917 noted multiple areas where bottom plating showed signs of leakage and corrosion. These conditions were not unusual for vessels of this age and service history, but they indicated a hull structure that was experiencing cumulative fatigue from years of operation. The single smokestack design of the USS Cyclops created a distinctive silhouette that made the vessel easily identifiable. The stack was positioned directly above the boiler rooms, with uptakes that channeled exhaust gases from the 4 coal-fired boilers. The boiler plant required constant attention from the engineering department to maintain steam pressure and manage coal consumption. Typical coal consumption for the USS Cyclops, operating at cruising speed, was approximately 75 tons per day, requiring careful management of bunker supplies during extended voyages. The electrical system aboard the USS Cyclops provided power for lighting, communications equipment, and auxiliary machinery. The ship was equipped with steam-driven generators that produced direct current electricity at 120 volts. The electrical distribution system included cables running throughout the vessel to supply power to various compartments and systems. Radio communication equipment installed in the wireless room allowed the ship to transmit and receive messages at ranges exceeding 100 nautical miles under favourable atmospheric conditions. The reliability of electrical systems in 1918 was significantly lower than modern standards, with frequent failures requiring troubleshooting and repair by the ship's electricians. The navigation equipment aboard the USS Cyclops consisted of magnetic compasses, chronometers for celestial navigation, and sounding equipment for determining water depth. The ship was equipped with both a standard compass mounted on the bridge and a steering compass located at the helm. Chronometers were maintained in temperature-controlled compartments to ensure accuracy for celestial navigation calculations. Lead lines and sounding machines allowed the crew to measure water depth in coastal areas where safe navigation required knowledge of bottom contours. The ship's boats and life-saving equipment included several wooden lifeboats carried on davits along the sides of the vessel. The lifeboat capacity was calculated to accommodate the crew and passenger complement, though launching boats in rough seas presented significant challenges. Life preservers were stored in accessible locations throughout the ship, and crew members received training in their use during emergency drills. Distress signal equipment included rockets, flares, and signal flags that could be used to indicate emergency situations to other vessels or shore stations. The structural design of Proteus-class colliers incorporated certain features that later analysis would identify as potential weaknesses. The relatively long hull length compared to beam width created a tendency for the vessel to flex in seaway conditions. Naval architects refer to this flexing as hogging and sagging, where the hull bends upward amidships during passage through wave troughs, and downward when supported by wave crests. Excessive hull flexing could cause stress fractures in structural members, particularly in areas where longitudinal strength was concentrated in the keel and bottom framing. The conversion of the USS Cyclops to ore transport service required minimal physical modification to the ship's structure. The existing cargo holds were suitable for bulk ore storage without significant alterations. Loading and unloading procedures for ore differed from coal handling primarily in the rate at which cargo could be transferred. Ore was typically loaded using clamshell buckets or conveyor systems that delivered material directly into the holds. The denser nature of ore meant that loading operations proceeded more slowly than coal loading to prevent damage to hold structures from concentrated impacts. The engineering maintenance requirements for vessels like the USS Cyclops were substantial. The propulsion machinery required regular overhaul and repair to maintain reliability. Boiler tubes required periodic replacement as they deteriorated from high-temperature operation and corrosion. Engine components experienced wear from friction and thermal stress. The ship's engineering department was responsible for conducting routine maintenance during voyages and coordinating major repairs during shipyard availability periods. The condition of the USS Cyclops' machinery in early 1918 reflected the cumulative effects of 7 years of continuous service. The twin-engine configuration provided redundancy for propulsion, allowing the vessel to continue operating if one engine failed. However, the loss of one engine significantly reduced the ship's maximum speed and maneuverability. Operating on a single engine also created an unbalanced thrust condition that affected steering characteristics. The starboard engine failure documented during the USS Cyclops' time in Rio de Janeiro meant the vessel was operating at reduced capability throughout her final voyage. The decision to proceed with only one functional engine represented a calculated risk based on the urgency of delivering the manganese ore cargo and the availability of repair facilities along the route. The hull plating of the USS Cyclops was constructed from mild steel plates, varying in thickness depending on location and structural requirements. The bottom plating was typically heavier than side plating to provide strength against grounding forces and to support cargo loads. The side plating increased in thickness near the waterline, where wave impact and structural stress were greatest. The deck plating was designed to support the weight of deck cargo and the concentrated loads from cargo handling equipment. All steel components were subject to corrosion from exposure to seawater, requiring regular maintenance and protective coating application. The cargo hold ventilation system was designed to prevent the accumulation of dangerous gases and to manage temperature during voyages. Natural ventilation was provided by ventilator cowls positioned on deck to capture wind and direct fresh air into the holds. Mechanical ventilation using steam-driven fans supplemented natural airflow when necessary. The ventilation system for all cargo served primarily to prevent moisture accumulation that could cause cargo to solidify or shift during transit. The effectiveness of ventilation depended on weather conditions and the ship's operating environment. The Structural Survey report from 1917 concluded with recommendations for repairs and modifications to address the identified deficiencies. The report specified that engine bed repairs should be completed during the next available shipyard period. Bottom plate repairs were recommended for areas showing advanced corrosion. The report noted that the vessel remained fit for service pending completion of the recommended work. The repairs were categorized as important but not immediately critical to vessel safety. The outbreak of World War I and the increased operational tempo of naval vessels created delays in implementing non-emergency repairs across the fleet. The naval architecture of early 20th century colliers represented a compromise between cargo capacity, structural strength, and operational flexibility. The USS Cyclops and her sister ships Proteus and Nereus embodied the engineering standards and design philosophy of their construction era. The ships were built to carry coal, a relatively light and voluminous cargo that filled the available hold space without exceeding structural load limits. The adaptation of these vessels to carry dense ore cargo pushed their design parameters beyond the intended operational envelope. The structural consequences of this adaptation would not be fully understood until decades after the USS Cyclops disappeared. Captain George W. Worley, born Johann Friedrich Georg Wichmann in Germany in 1862, had commanded the USS Cyclops since May 10, 1912. His appointment to command the collier came after years of service in the United States Merchant Marine and represented the culmination of a career that had begun in German merchant shipping before his immigration to America. Worley's background as a German-born officer commanding a United States Navy vessel during World War I would later fuel speculation about the circumstances of the ship's disappearance, though no evidence ever suggested disloyalty or sabotage. The details of Worley's early life in Germany remain fragmentary in official records. He was born in the northern German states during the period of Prussian dominance that preceded German unification in 1871. His decision to immigrate to the United States occurred sometime during the 1880s, part of the wave of German immigration that brought millions of Germans to America during the late 19th century. Upon arrival in the United States, he adopted the anglicized name George W. Worley, abandoning his birth name of Johann Friedrich Georg Wichmann. The reasons for this name change were typical of immigrants seeking to assimilate into American society and advance in professions where German origins might create obstacles. Worley obtained United States citizenship through naturalization proceedings conducted in a federal court, though the exact date and location of his naturalization have been disputed in various accounts. Naturalization in the late 19th century required a period of residency, demonstration of good moral character, and renunciation of allegiance to foreign sovereigns. The naturalization process for German immigrants was generally straightforward, as Germans were considered desirable immigrants due to their reputation for industriousness and technical skill. Worley's naturalization allowed him to serve aboard American-flagged vessels and eventually to obtain a commission in the United States Navy. His maritime career began in the merchant service, where he accumulated the sea time and experience necessary to advance through the ranks of ships' officers. Merchant marine officers in this era typically progressed from third mate to second mate to first mate before achieving command of their own vessels. Worley's progression through these ranks required passing examinations administered by the United States Steamboat Inspection Service, demonstrating knowledge of navigation, seamanship, and maritime regulations. His experience included service aboard coal-carrying vessels, which provided the specialized knowledge that would prove relevant to his later command of naval colliers. The United States Navy commissioned Worley as a lieutenant commander and assigned him to auxiliary vessel duty. His commission came during a period when the Navy was expanding its collier fleet to support the growing number of coal-fired warships. Officers with merchant marine experience in cargo operations were considered valuable additions to the auxiliary force. Worley's appointment to command the USS Cyclops in 1912 placed him in charge of one of the Navy's largest and most important colliers, responsible for transporting thousands of tons of coal to support fleet operations. Crew members who served under Worley's command provided conflicting assessments of his leadership style and personal character. Some sailors described him as a demanding but fair commander who maintained high standards for ship operations. Others characterized him as tyrannical and arbitrary in his treatment of subordinates. Disciplinary records from the USS Cyclops showed that Worley had confined several crew members to the brig for various infractions during his tenure as commanding officer. The rate of disciplinary actions aboard the USS Cyclops was not unusual for naval vessels of this period, but some crew members complained that Worley's punishments were excessive for minor violations. Physical descriptions of Worley emphasized his eccentric personal habits and unconventional appearance for a naval officer. He was reported to stand approximately 5 feet 6 inches tall, with a stocky build and a full beard that was unusual among naval officers of this era. Multiple witnesses described his habit of wearing a derby hat or bowler while on the bridge, a civilian fashion accessory that violated naval uniform regulations, but which Worley apparently considered more comfortable than the standard officer's cap. Even more notably, crew members reported that Worley would sometimes walk the ship's deck wearing only his underwear during hot weather, behaviour that scandalised junior officers and enlisted personnel accustomed to strict uniform standards. The commanding officer's cabin aboard the USS Cyclops reflected Worley's personal eccentricities. He reportedly kept numerous books on nautical subjects and navigation, suggesting serious professional interest in his craft. His cabin also contained personal effects that indicated his German heritage, though the extent of these items and their significance remained subjects of speculation after the ship's disappearance. Worley's private behaviour aboard ship was described as solitary, with limited social interaction with his officers outside of official duties. Fitness reports prepared by superior officers who inspected the USS Cyclops during Worley's command showed generally satisfactory assessments of his professional performance. The ship maintained acceptable standards of cleanliness and operational readiness during inspections. Cargo operations were conducted efficiently, and the vessel met its scheduled commitments for coal deliveries to fleet units. These official evaluations suggested that whatever personal eccentricities Worley displayed, he was capable of managing the technical and administrative requirements of commanding a naval auxiliary vessel. The outbreak of World War I in 1914 and American entry into the conflict in 1917 created new pressures on all naval officers, particularly those of German birth or descent. The United States government implemented security measures to identify and monitor individuals with potential divided loyalties. German-born naturalized citizens faced particular scrutiny, with some being interned or restricted in their activities based on suspicions about their allegiance. Naval personnel with German backgrounds were investigated to ensure they posed no security risk to military operations. Worley's German birth became a subject of official interest following American entry into World War I. Naval intelligence conducted background investigations on officers with foreign birth, particularly those from enemy nations. The investigation into Worley's background examined his naturalization status, his family connections in Germany, and his conduct since assuming American citizenship. The investigation found no evidence of pro-German sympathies or activities that would disqualify him from naval service. The Navy Department concluded that Worley was a loyal American officer who happened to have been born in Germany before immigrating to the United States decades earlier. Crew members who served under Worley during the war years reported no incidents suggesting divided loyalty or suspicious behaviour related to his German origins. He conducted ship operations according to Navy regulations and followed orders from superior commanders without incident. His personal correspondence, which would be examined after his disappearance, contained no evidence of communications with German nationals or expressions of sympathy for the German cause. The available evidence indicated that Worley had fully committed to his adopted country and his role as a United States Navy officer. The relationship between Worley and his officers aboard the USS Cyclops was described as professionally correct, but not particularly warm. The commanding officer maintained formal distance from his subordinates, a command style that was not unusual in the Navy of this era. Officers reported that Worley was exacting in his requirements for watchkeeping and ship handling, but did not engage in unnecessary criticism or abuse. The executive officer and department heads managed day-to-day operations with limited interference from the captain, suggesting a delegation of authority that reflected confidence in his senior subordinates. Worley's navigation style emphasized caution and adherence to established routes. He preferred to follow well-marked shipping lanes and to make frequent position checks using coastal landmarks when operating near shore. His approach to navigation was conservative rather than innovative, relying on proven techniques rather than experimental methods. This conservative style was appropriate for commanding a cargo vessel where safe delivery of cargo was the primary mission rather than speed or tactical maneuver. The commanding officer's behaviour during the USS Cyclops' final voyage attracted particular attention from witnesses who observed him in Barbados during the ship's last port call. British colonial officials who met with Worley noted that he appeared concerned about his ship's mechanical condition, but did not express unusual alarm about safety. His demeanour was described as businesslike and focused on operational matters. He inquired about weather forecasts for the route to Baltimore and discussed the ship's coal requirements with port authorities. These interactions suggested a commander attending to routine matters rather than someone anticipating disaster. Personal habits that crew members had observed throughout Worley's command continued during the final voyage. He maintained his usual schedule of inspecting the ship's spaces and observing cargo operations. His interactions with passengers aboard for the journey from Rio de Janeiro to Baltimore were limited, as was typical of his preference for maintaining distance from non-essential personnel. Consul General Gottschalk, who was among the passengers, had brief conversations with Worley about the voyage timeline and expected arrival in Baltimore, but these discussions were routine rather than notable. The question of Worley's competence to command the USS Cyclops during her final voyage would be examined extensively after the ship's disappearance. His decision to proceed from Rio de Janeiro with only one functional engine was criticised by some investigators as reckless. Others argued that operating on a single engine was within acceptable risk parameters for a collier making a coastal transit with opportunities to divert to intermediate ports if conditions worsened. The decision reflected standard practice for auxiliary vessels during wartime, when operational demands often required accepting higher levels of risk than peacetime standards would permit. Worley's final communications from Barbados gave no indication that he anticipated serious problems during the voyage to Baltimore. His messages to naval authorities outlined the ship's expected route and estimated arrival time. He reported the mechanical status of the vessel, noting the inoperative starboard engine, but expressing confidence that the remaining engine was sufficient for the transit. These communications followed standard reporting procedures and contained no unusual elements that would have alerted shore-based commanders to potential difficulties. The commanding officer's fate, along with that of his entire crew and passengers, remained unknown after the USS Cyclops disappeared. No evidence ever emerged to suggest that Worley had deliberately caused or contributed to the ship's loss. The investigation into the disappearance found no indication of sabotage, mutiny, or intentional scuttling. Captain George W. Worley vanished with his ship on March 4, 1918, leaving behind a record of competent, if eccentric, service and an unresolved question about the final moments of command aboard the doomed collier. Manganese ore is a dense mineral compound with a specific gravity ranging from 3.6 to 4.2, depending on the precise composition and moisture content. This density makes manganese ore approximately 4 times heavier than water and substantially heavier than coal, which has a specific gravity of approximately 0.8 to 1.0. The weight differential between coal and manganese ore created fundamental challenges for vessels designed to carry coal when they were converted to ore transport service. A cubic foot of bituminous coal weighs approximately 50 to 60 pounds, while a cubic foot of manganese ore weighs between 225 and 260 pounds. This density difference meant that cargo holds designed to be filled completely with coal would be dangerously overloaded if filled to capacity with manganese ore. The strategic importance of manganese ore during World War I stemmed from its essential role in steel production. Manganese serves as a deoxidizing and desulfurizing agent in the steelmaking process, removing impurities that would otherwise make steel brittle and unsuitable for military applications. Steel used in armor plate, artillery shells, and structural components for ships and vehicles required manganese content, typically ranging from 0.3 to 1.5% by weight. The United States steel industry consumed approximately 500,000 tons of manganese ore annually during the war years, with domestic production insufficient to meet demand. Brazil had emerged as a major source of high-grade manganese ore, with mines in Minas Gerais producing ore containing 45 to 52% manganese content. The loading operations for the USS Cyclops in Rio de Janeiro during late February 1918 involved transferring 10,800 tons of manganese ore from shore facilities to the ship's cargo holds. The ore had been transported by rail from inland mining districts to the port of Rio de Janeiro, where it was stockpiled awaiting shipment. Loading procedures required careful attention to weight distribution to maintain the ship's stability and trim. Longshoremen used clamshell buckets suspended from dockside, cranes to transfer ore from the stockpile to the ship's holds. Each bucket load weighed approximately 1 to 2 tons, and the loading process required several days to complete. The distribution of cargo within the 5 cargo holds of the USS Cyclops required careful calculation to prevent excessive stress on the ship's structure and to maintain proper floating characteristics. Naval cargo officers were responsible for preparing loading plans that specified how much cargo should be placed in each hold and at what vertical level within each hold. The loading plan for dense cargo, like manganese ore, differed fundamentally from plans for coal cargo. Coal would naturally fill holds from bottom to top, distributing weight relatively evenly throughout the hold volume. Manganese ore, being much denser, would occupy only the lower portions of the holds if loaded to the ship's weight capacity, creating a low center of gravity and concentrating weight on the bottom plating. The concept of free surface effect presented a significant hazard for vessels carrying bulk cargo that could shift during transit. Free surface effect occurs when loose cargo moves within a hold in response to the ship's motion, creating a shifting weight that can affect stability. When a ship rolls to one side, cargo on the high side can slide downward toward the low side, adding to the rolling moment and potentially causing the ship to capsize. Bulk cargo, like coal or ore, is particularly susceptible to free surface effect if not properly secured or if the cargo settles and creates void spaces within the hold. The prevention of free surface effect requires either filling holds completely, so cargo cannot shift, or installing temporary bulkheads to divide large holds into smaller compartments. The moisture content of manganese ore affected both its weight and its behaviour during transport. Ore freshly mined and processed typically contains moisture from washing and separation processes. During ocean transport, this moisture can migrate within the cargo mass, potentially creating pockets of saturated ore that behave differently from dry ore. Saturated ore can become semi-fluid under certain conditions, flowing like a thick liquid rather than remaining solid. This liquefaction of ore cargo has caused numerous ship losses throughout maritime history, as the flowing cargo creates severe stability problems that can lead to rapid capsizing. The cargo hold configuration aboard the USS Cyclops provided limited ability to prevent cargo shifting. The holds were designed with smooth steel sides and bottoms to facilitate coal handling, with no built-in subdivisions or cargo securing points. Temporary wooden bulkheads could be installed to create compartments within holds, but this required additional materials and labour that might not have been available in Rio de Janeiro. The decision about whether to install shifting boards or other cargo restraint systems would have been made by the ship's cargo officer based on the expected sea conditions and the characteristics of the specific ore being loaded. Engineering analysis of ore cargo stability involves calculating the ship's metacentric height, a measure of initial stability that indicates how forcefully the vessel will return to upright position after rolling. A ship with high metacentric height will snap back to upright quickly after rolling, creating a stiff and uncomfortable motion. A ship with low metacentric height will roll more slowly and may feel more comfortable, but has reduced ability to resist capsizing forces. The loading of dense cargo in the bottom of holds lowers the centre of gravity, which increases metacentric height. However, if the cargo can shift, the stability advantage of low centre of gravity is negated by the destabilizing effect of moving weight. The structural load imposed by 10,800 tons of manganese ore exceeded the design parameters of the USS Cyclops in several respects. The bottom plating and framing were designed to support the distributed weight of coal cargo throughout the hold volume. Concentrated ore cargo created point loads, where the ore contacted the bottom plating, stressing the steel beyond its design limits. The hold framing members, including floor plates and longitudinal girders, experienced higher stress than in coal service. These structural loads were further amplified by dynamic forces when the ship encountered rough seas, as the cargo weight would impact against the bottom plating with each wave motion. Comparison with previous ore transport incidents in other vessels provided limited guidance for assessing the risks faced by the USS Cyclops. Several colliers and bulk cargo vessels had experienced difficulties or losses while carrying ore cargoes in the years preceding 1918. The British collier SS Waratah had disappeared in 1909 while carrying ore concentrate, though that loss was attributed primarily to stability problems inherent in the ship's design. The American vessel SS Marine Sulphur Queen would later vanish in 1963 while carrying molten sulphur, another dense cargo that created challenges for vessels not specifically designed for such service. These precedents suggested that adapting coal carriers to ore transport involved risks that were not fully understood by ship operators and naval authorities. The inspection procedures for OR cargo loading in 1918 were less rigorous than modern standards. Port officials in Rio de Janeiro would have verified the quantity of cargo loaded for customs and billing purposes, but technical inspection of cargo distribution and hold conditions was primarily the responsibility of the ship's officers. Captain Worley and his cargo officer would have made decisions about how to distribute the ore among the 5 holds based on their experience and judgment. No external regulatory authority mandated specific loading procedures or conducted independent safety inspections of cargo operations for naval vessels. The chemical composition of the specific manganese ore loaded aboard the USS Cyclops in Rio de Janeiro consisted primarily of manganese dioxide with varying amounts of iron oxides, silica, and other mineral impurities. The ore from Brazilian sources typically assayed at 45 to 52% manganese content, which was considered high grade and commanded premium prices in international markets. The remainder of the ore consisted of gangue material that had no commercial value but contributed to the cargo weight. The presence of iron oxides in the ore meant that the cargo would be subject to rust and corrosion when exposed to moisture, potentially affecting its handling characteristics during the voyage. The temperature of ore cargo during ocean transport could vary depending on ambient conditions and the exothermic chemical reactions that sometimes occur in ore masses. Freshly mined ore might retain heat from processing operations or from chemical oxidation of sulfide minerals. The cargo holds of the USS Cyclops were not insulated or temperature controlled, so the ore temperature would gradually equalize with the ambient air and seawater temperatures. Temperature variations within the cargo mass could create convection currents that moved moisture through the ore, potentially contributing to liquefaction problems. The ballast water management aboard the USS Cyclops required careful coordination with cargo loading operations. Ships used ballast water in dedicated tanks or empty holds to maintain proper trim and stability when carrying partial cargo loads. The dense manganese ore cargo lowered the ship's center of gravity significantly, potentially eliminating the need for ballast water in the bottom tanks. However, if ballast tanks were not completely emptied after loading ore, the free surface of water in partially filled tanks could create additional stability problems. The interaction between ballast water management and ore cargo loading was a complex calculation that required expertise in ship stability principles. The ventilation of ore-filled cargo holds served multiple purposes beyond simple air circulation. Adequate ventilation prevented the accumulation of dangerous gases that might be released from the ore, including carbon monoxide from oxidation reactions or hydrogen sulfide from sulfide minerals. Ventilation also helped manage moisture content by allowing humid air to escape and drier air to enter. The ventilation system aboard the USS Cyclops consisted of natural ventilation through cowls and openings on deck, supplemented by mechanical ventilation fans in some compartments. The effectiveness of ventilation depended on maintaining proper airflow patterns and ensuring that ventilation openings remained clear of obstructions. The precedent for naval colliers carrying ore cargo existed in limited form prior to the USS Cyclops' final voyage. The Navy had occasionally used colliers to transport ore and other dense cargoes when cargo space was available and naval vessels were positioned conveniently for such service. These previous ore transport missions had generally been completed without incident, creating confidence that colliers could safely handle ore cargoes despite not being specifically designed for such service. The accumulation of experience with ore transport had not included sufficient analysis of the loading conditions and sea states that might create dangerous situations. The economic value of the 10,800 tons of manganese ore aboard the USS Cyclops represented a substantial financial asset. High-grade manganese ore commanded prices of approximately $30 to $40 per ton in 1918, making the cargo worth between $320,000 and $430,000. This value exceeded the annual operating cost of the vessel and represented strategic material that the United States steel industry required for war production. The loss of the cargo, while significant, was overshadowed by the human tragedy and the loss of the naval vessel itself. The long-term implications of ore cargo for vessel structural integrity involved cumulative damage that might not be immediately apparent. Each voyage with dense ore cargo subjected the hull structure to stress cycles that caused microscopic cracks and deformation in steel members. Over multiple voyages, this cumulative damage could lead to sudden structural failure when critical stress thresholds were exceeded. The USS Cyclops had carried coal for most of her service life, with ore transport representing a relatively recent adaptation to wartime cargo demands. The extent of structural deterioration from ore service would have been difficult to assess without detailed inspection, beyond the routine surveys conducted by Navy shipyards. Modern understanding of bulk cargo behaviour has advanced significantly since 1918, incorporating lessons learned from numerous cargo shift incidents and capsizing events. Current international maritime regulations specify detailed procedures for loading and securing bulk cargoes, including requirements for moisture content testing, cargo hold preparation, and loading sequence verification. These regulations developed in response to continued losses of vessels carrying bulk cargoes, demonstrating that the hazards faced by the USS Cyclops were not fully understood or adequately addressed during her operational period. The manganese ore cargo that the ship carried on her final voyage represented a hidden danger that naval authorities and ship operators did not fully recognize until experience demonstrated the deadly consequences of their oversight. The USS Cyclops departed Barbados on March 4, 1918, carrying exactly 309 people, 236 enlisted sailors, 15 commissioned officers, and 58 civilian passengers. This complement represented one of the largest groups of personnel ever lost in a single incident in United States naval history. The crew roster included sailors from ports throughout the Atlantic seaboard, while the passenger manifest documented civilians from multiple nations who had been working or traveling in South America and were returning to the United States via naval transport. The commanding officer, Captain George W. Worley, led a wardroom of 14 additional commissioned officers who served as department heads and watchstanders. Lieutenant John G. Church served as executive officer, responsible for managing daily ship operations and crew discipline. Lieutenant Commander Albert E. Yancey held the position of navigator, tasked with plotting the ship's course and maintaining accurate position records. The chief engineer, Lieutenant Robert S. Jackson, supervised the engineering department and the troubled propulsion machinery. Additional officers included the supply officer, gunnery officer, and several junior officers who stood watches and supervised divisions of enlisted personnel. The enlisted crew of 236 men included specialists in multiple ratings essential to ship operations. The deck department consisted of boatswain's mates, quartermasters, and seamen who handled navigation, cargo operations, and general maintenance. The engineering department employed machinists' mates, firemen, and coal passers who maintained and operated the propulsion plant. Electricians' mates managed the ship's electrical systems and radio equipment. Ship's cooks and stewards provided food service and maintained berthing spaces. Each rating required specific training and experience, with senior petty officers supervising less experienced sailors. Among the enlisted personnel were several men with extensive naval service who had been aboard the USS Cyclops for multiple years. Chief Boatswain's Mate James F. Thompson, age 42, had served in the Navy since 1895 and had been assigned to the Cyclops since 1914. Chief Machinist's Mate William R. Price, age 38, had joined the Navy in 1902 and had been responsible for maintaining the ship's engineering plant since 1913. These experienced petty officers provided continuity and technical expertise that was essential to operating the aging collier under wartime conditions. The passenger list of 58 civilians included American Consul General Alfred L. M. Gottschalk and his family. Gottschalk had served as Consul General in Rio de Janeiro since 1915, representing American commercial and diplomatic interests in Brazil. His wife, Louise Gottschalk, and their two daughters, 16-year-old Eloise and 14-year-old Marguerite, were travelling with him on their return to the United States. The Consul General's assignment in Rio de Janeiro had concluded, and he was being reassigned to a new posting. The family's luggage included personal effects accumulated during 3 years of residence in Brazil. Several American mining engineers and businessmen who had been working in Brazil's mineral extraction industry were among the passengers. George W. Worth, a 45-year-old mining engineer from Denver, Colorado, had spent 2 years managing operations at a manganese mine in Minas Gerais. His expertise in ore extraction and processing had made him valuable to Brazilian mining companies supplying material for the Allied war effort. Worth was returning to the United States for consultation with American steel manufacturers about ore specifications and quality control. John H. Starr, a 52-year-old business executive from Pittsburgh, Pennsylvania, had been negotiating contracts for manganese ore purchases on behalf of United States Steel Corporation. His assignment in Brazil had lasted 6 months, during which he had visited multiple mining operations and established supply relationships with Brazilian ore producers. Starr carried business documents and ore samples that were intended to support continued commercial relationships between American steel companies and Brazilian suppliers. The passenger manifest also included several Brazilian nationals who were travelling to the United States for business or educational purposes. These passengers carried proper documentation for entry into the United States and had booked passage aboard the USS Cyclops. Because civilian passenger ship service between Brazil and North America had been disrupted by wartime conditions, naval auxiliary vessels like the Cyclops occasionally carried civilian passengers when space was available and when the passengers had valid reasons for travel related to the war effort. Families travelling together aboard the USS Cyclops included not only the Gottschalk family, but also several crew members' dependents who'd been granted passage for compassionate reasons. Navy regulations permitted commanding officers to authorize dependent travel aboard auxiliary vessels under certain circumstances, particularly when family members needed to relocate due to personnel reassignments. The exact number of family members among the passenger count varied in different accounts, but at least 3 wives and 2 children of crew members were documented among the civilians aboard. The crew's ethnic composition reflected the diversity of American port cities in the early 20th century. Sailors with Irish, Italian, German, Polish, and Scandinavian surnames appeared on the crew roster, representing the immigrant communities that supplied much of the labour for American maritime industries. Some crew members were first-generation Americans whose parents had immigrated during the late 19th century. Others were themselves immigrants who had obtained American citizenship and enlisted in the Navy to demonstrate their loyalty to their adopted country. The youngest crew member aboard the USS Cyclops was Seaman Apprentice Robert C. Wilson, who had enlisted in the Navy at age 17 and was assigned to the Cyclops as his first ship. Wilson's parents in Norfolk, Virginia, received their son's last letter from Barbados, in which he described the voyage from Rio de Janeiro and expressed eagerness to return home after several months at sea. The letter contained no indication of concern about the ship's condition or the upcoming voyage to Baltimore. The oldest crew member was Chief Carpenter John P. Murphy, age 58, who had served in the Navy since 1882 and had been aboard the Cyclops since her commissioning in 1910. Murphy's responsibilities included maintaining the ship's wooden structures, including deck planking, hatches, and temporary cargo restraints. His extensive experience made him valuable for assessing structural damage and organising repair work when the ship encountered mechanical difficulties. Several crew members had kept personal journals or written letters that provided insights into conditions aboard the USS Cyclops during her final voyage. These documents, which were sent ashore at various ports and later examined by investigators, described routine shipboard life with occasional references to mechanical problems and cargo operations. The tone of these writings suggested that crew members considered the voyage from Rio de Janeiro to Baltimore to be routine despite the inoperative engine and the unusual cargo. The ship's medical officer, Surgeon Lieutenant Harold K. Roberts, was responsible for treating illness and injuries among the crew and passengers. Roberts maintained medical records documenting sick call visits and treatments administered during voyages. The medical log from the voyage segment between Rio de Janeiro and Barbados showed routine cases of minor injuries and seasonal illnesses with no epidemic diseases or serious medical emergencies. Roberts had requested medical supplies at Barbados to replenish stocks for the final leg to Baltimore. Personal effects belonging to crew members and passengers remained aboard the USS Cyclops when she departed Barbados. Sailors kept their clothing and personal items in sea bags stored in berthing compartments. Officers maintained personal effects in their staterooms. Passengers had luggage that was stowed in passenger accommodations or in designated baggage storage areas. The total value of personal property aboard the ship was estimated at several $1,000s, though most items were of sentimental rather than monetary value. Letters and messages sent ashore from Barbados during the brief port call represented the final communications from many aboard the USS Cyclops. These letters were posted through British colonial mail services and reached their destinations in the United States during the weeks following the ship's disappearance. Family members who received these final letters preserved them as the last words from their loved ones. The content of the letters was uniformly optimistic, with no expressions of concern about the upcoming voyage. The crew's morale during the final voyage appeared to be adequate based on reports from observers who had contact with the ship in Rio de Janeiro and Barbados. Crew members who went ashore during port calls behaved normally and showed no signs of unusual stress or anxiety. Officers who interacted with port officials conducted themselves professionally and discussed routine operational matters. The absence of disciplinary problems or reports of crew dissatisfaction suggested that morale remained within acceptable parameters for a naval vessel in wartime service. The diversity of backgrounds and experiences among the 309 people aboard the USS Cyclops created a cross-section of American and international society in early 1918. Naval officers from established families served alongside enlisted sailors from working-class backgrounds. American diplomats and businessmen traveled with Brazilian nationals seeking opportunities in the United States. Experienced petty officers with decades of service worked with teenage seamen on their first assignments. This mixture of individuals, united temporarily by their presence aboard a single vessel, would share a common fate when the ship vanished without trace. The total count of 309 people aboard the USS Cyclops when she departed Barbados on March 4, 1918, was documented in official naval records and confirmed by port authorities who observed the ship's departure. This number included every person who boarded the vessel in Rio de Janeiro or Barbados and who remained aboard when the ship sailed for Baltimore. No passengers or crew members disembarked at Barbados, and no additional personnel boarded during the port call. The 309 individuals represented the complete manifest of the ship's final voyage. On January 8, 1918, the USS Cyclops arrived at Rio de Janeiro, Brazil, with orders to load manganese ore for transport to the United States in support of the war effort. The mission had been assigned by the Navy Department as part of the Strategic Materials Procurement Program that supplied critical minerals to American steel manufacturers. The voyage from Norfolk to Rio de Janeiro had taken approximately 3 weeks, with the ship travelling southward along the Atlantic coast of South America to reach the Brazilian port. The crew had anticipated a routine cargo loading operation, followed by the return transit to Baltimore or another East Coast port. The harbour at Rio de Janeiro provided adequate facilities for loading bulk cargo, with dockside cranes and warehouses that served the commercial shipping trade. The USS Cyclops was assigned a berth near the ore loading facilities where manganese ore from inland mines had been stockpiled for export. Brazilian port officials coordinated with American naval representatives to arrange the loading schedule and to provide the necessary labour force for cargo operations. The ore had been transported by rail from mining districts in Minas Gerais, arriving in Rio de Janeiro in railway cars that delivered the material directly to dockside storage areas. The quantity of ore designated for loading aboard the USS Cyclops was specified in the mission orders as approximately 11,000 tons. This tonnage represented the maximum cargo capacity that Navy planners believed the vessel could safely carry given her structural condition and the density of manganese ore. The actual amount loaded would be determined by the ship's cargo officer based on trim and stability calculations performed during the loading process. The ore loading began within days of the ship's arrival, with longshoremen working in shifts to transfer material from shore stockpiles to the cargo holds. The loading procedure employed clamshell buckets suspended from dockside cranes. Each bucket could hold approximately 1 to 2 tons of ore, and the crane operators positioned the buckets over designated hatches to release the ore into specific holds. The cargo officer supervised the operation from the ship's deck, directing which holds should receive cargo and monitoring the ship's draft marks to track the total weight loaded. The process required constant attention to ensure even distribution of weight between the forward and after holds to maintain proper trim. The ore loaded aboard the USS Cyclops consisted of high-grade manganese ore, assaying at approximately 48 to 50% manganese content. The ore appeared as dark brown to black chunks ranging in size from fine gravel to pieces several inches in diameter. The material was relatively dry, having been stored under cover in warehouse facilities that protected it from rain. The consistency of the ore allowed it to flow freely through loading equipment, though the individual pieces were heavy enough that manual handling by workers was physically demanding. As the loading operation progressed, the USS Cyclops settled deeper into the water as her displacement increased with each ton of cargo. The ship's draft marks indicated the depth of the hull below the waterline, with measurements taken at bow, midships, and stern positions. The cargo officer recorded these measurements at regular intervals to calculate the total weight loaded and to verify that the ship maintained acceptable trim. The final draft readings after loading completion showed the vessel drawing approximately 28 feet of water, deeper than her typical draft when carrying coal cargo. The engineering department discovered serious mechanical problems with the starboard engine during the time the USS Cyclops was in Rio de Janeiro. Routine maintenance inspections revealed that the starboard engine's main shaft bearings had developed excessive wear, creating vibration and noise during engine operation. The chief engineer, Lieutenant Jackson, reported the condition to Captain Worley and recommended that repairs be undertaken before the ship departed for the return voyage. The repairs would require removing the shaft to replace the bearings, a process that could take several weeks using the limited facilities available in Rio de Janeiro. The specific nature of the engine problem involved the bearing surfaces that supported the propeller shaft where it passed through the engine room bulkhead. These bearings required precise alignment and adequate lubrication to function properly. The wear that had developed created clearances that allowed the shaft to vibrate excessively during rotation. Continued operation of the engine in this condition risked additional damage to the shaft itself or to the bulkhead stuffing box, where the shaft exited the hull. The potential for catastrophic failure existed if the vibration caused shaft misalignment, severe enough to damage the stern tube or propeller. Captain Worley faced a decision about whether to undertake repairs in Rio de Janeiro or to proceed with the voyage operating on the port engine alone. The repair timeline would delay the cargo delivery by at least a month, disrupting schedules for steel production in the United States. Operating on a single engine was technically feasible for the relatively short voyage to Baltimore, particularly given the availability of intermediate ports where emergency assistance could be obtained if needed. The Navy Department had not issued specific guidance about acceptable risk levels for auxiliary vessels operating with degraded machinery. The decision to proceed without repairing the starboard engine was documented in the ship's log and in messages transmitted to the Navy Department. Captain Worley reported the mechanical condition and his intention to operate on the port engine during the return voyage. The Navy Department acknowledged the report but did not order the ship to remain in Rio de Janeiro for repairs. The implicit approval of proceeding with one engine reflected the wartime operational tempo that often required accepting higher risk levels than peacetime standards would permit. The port engine underwent thorough inspection and maintenance while the ship was in Rio de Janeiro to ensure its reliability for the voyage ahead. Engineering personnel cleaned and lubricated the engine components, checked valve clearances, and tested the governor systems that regulated engine speed. The boiler plant was also inspected, with tubes cleaned and water chemistry adjusted to minimize corrosion. These maintenance activities provided confidence that the remaining operational engine could sustain continuous operation for the duration of the voyage to Baltimore. The fuel bunkers aboard the USS Cyclops were loaded with coal to provide sufficient capacity for the return voyage. The calculation of coal requirements considered the reduced speed capability when operating on a single engine and the increased fuel consumption that would result from the additional weight of the ore cargo. The ship's bunkers could hold approximately 2,800 tons of coal, providing enough fuel for the voyage to Baltimore with reserves for contingencies. The actual amount of coal loaded was determined by the space remaining after ore loading and by weight considerations to avoid exceeding the ship's maximum displacement. The departure from Rio de Janeiro was scheduled for February 16, 1918, after the completion of cargo loading operations and the necessary maintenance work on the port engine. Brazilian port authorities cleared the vessel for departure after verifying that customs documentation was in order and that port fees had been paid. American consular officials in Rio de Janeiro were notified of the ship's departure and the expected arrival date in Baltimore. The weather forecast for the South Atlantic showed generally favorable conditions, with no severe storms predicted along the projected route. The crew completed final preparations for sea during the hours before departure. Deck department personnel secured cargo hatches and stowed loading equipment. The engineering department lit off additional boilers to provide steam for the port engine and auxiliary machinery. The navigation department verified that charts for the voyage were current and that navigation equipment was functioning properly. These preparations followed standard Navy procedures for vessels departing port. The passenger complement that would accompany the USS Cyclops from Rio de Janeiro to Baltimore was still being finalized during the ship's time in port. Consul General Gottschalk and his family had confirmed their intention to travel aboard the vessel, and their luggage was loaded several days before departure. Other passengers who had requested transportation were evaluated by the ship's executive officer to ensure that adequate accommodations were available and that their travel was consistent with Navy regulations regarding civilian passengers aboard auxiliary vessels. The USS Cyclops departed Rio de Janeiro on the afternoon of February 16, 1918, proceeding under power from the port engine alone. The ship's speed through the water was reduced to approximately 8 to 10 knots compared to the normal cruising speed of 12 knots, with both engines operational. The single propeller created an asymmetric thrust condition that required constant helm correction to maintain a straight course. These operating limitations were manageable, but required increased attention from the deck watch and helmsman. The initial segment of the voyage took the USS Cyclops northward along the Brazilian coast toward the port of Bahia, where a brief stop was planned to take on additional coal and to allow the engineering department to assess the port engine's performance. The distance from Rio de Janeiro to Bahia was approximately 700 nautical miles, requiring approximately 3 to 4 days of transit time at reduced speed. The sea conditions along this coastal route were generally moderate, with prevailing winds from the southeast creating following seas that aided the ship's progress. Crew members wrote letters during the days in Rio de Janeiro that were posted through Brazilian mail services before the ship departed. These letters described the cargo loading operations and mentioned the engine problems that would require operating on reduced power during the return voyage. The tone of the correspondence suggested that crew members viewed the mechanical situation as an inconvenience rather than a serious safety concern. The letters anticipated arrival in Baltimore during early March and looked forward to liberty after several months of continuous sea duty. The engineering log maintained by the USS Cyclops documented the port engine's performance during the departure from Rio de Janeiro and the initial days of the voyage northward. The log entries showed that the engine operated smoothly at reduced power settings and that no additional mechanical problems developed during this period. The fuel consumption rate was recorded at each watch change, allowing the chief engineer to verify that coal supplies would be adequate for reaching Bahia and continuing onward to Barbados and Baltimore. The cargo of 10,800 tons of manganese ore remained stable in the holds during the initial days of the voyage. The cargo officer conducted daily inspections of the hold spaces, checking for any signs of cargo shifting or water accumulation in the bilges. The ore showed no tendency to liquefy or flow, maintaining its solid character as the ship moved through moderate seas. The stability of the ship appeared adequate, though the reduced freeboard resulting from the heavy cargo meant that waves occasionally washed across the main deck during rough weather. The USS Cyclops arrived at Bahia on February 20, 1918, after an uneventful 4-day transit from Rio de Janeiro. The brief port call allowed the crew to take on approximately 400 tons of coal to replenish bunkers and to verify that the port engine continued to operate reliably. Captain Worley met with American consular officials in Bahia who provided updated information about shipping conditions along the route to the United States. The ship departed Bahia on February 22, 1918, bound for Barbados, the next scheduled stop on the voyage to Baltimore. The route from Bahia to Barbados covered approximately 1,200 nautical miles across the South Atlantic Ocean. This segment represented the longest overwater portion of the voyage, with no intermediate ports available for emergency assistance. The passage required approximately 10 to 12 days at the reduced speed achievable with one engine. The navigation plan called for the ship to steer a generally northward course, passing to the east of the Caribbean islands before turning westward to approach Barbados from the southeast. On March 3, 1918, at approximately 3 p.m. local time, the USS Cyclops dropped anchor in Carlisle Bay, Barbados, for what would be her final port call. The ship had completed the 10-day transit from Bahia without incident, operating continuously on the port engine while the starboard engine remained inoperative. The crew had maintained normal watch schedules during the passage, and the engineering department reported no new mechanical difficulties with the functioning engine. The arrival in Barbados marked the completion of the longest overwater segment of the voyage, with only the relatively short transit to Baltimore remaining before the mission would be complete. The harbour at Bridgetown, Barbados, served as a regular port of call for both commercial and military vessels transiting between South America and North America. British colonial authorities maintained port facilities that included coal bunkers, fresh water supplies, and provisions for vessels requiring resupply. The harbour master assigned the USS Cyclops an anchorage in Carlisle Bay, where the ship could take on coal and water without occupying limited dock space. Small boats ferried supplies from shore to the anchored vessel, while coal lighters delivered fuel directly to the ship's bunkers. British Consul B.S. Mayers visited the USS Cyclops shortly after her arrival to conduct the customary courtesy call on the commanding officer of a visiting naval vessel. Mayers met with Captain Worley in the ship's wardroom, where they discussed the vessel's condition and the planned continuation of the voyage to Baltimore. The consul later documented his observations in an official report that would become significant evidence in the subsequent investigation into the ship's disappearance. Mayers noted that Captain Worley appeared concerned about the inoperative starboard engine, but expressed confidence that the port engine was functioning adequately for the remaining voyage. According to the British consul's report, the USS Cyclops showed visible signs of heavy loading and mechanical stress. The ship was riding low in the water due to the weight of the manganese ore cargo, with minimal freeboard visible above the waterline. The single smokestack emitted smoke from the operating boilers, while the lack of exhaust from the inoperative engine systems was apparent to observers familiar with ship operations. Mayers described the vessel's appearance as workmanlike, but not alarming, noting that cargo vessels often displayed similar characteristics when fully loaded. Harbour officials in Bridgetown observed the crew's behaviour during the brief port call and reported no unusual circumstances that would suggest morale problems or operational difficulties beyond the known engine trouble. Sailors who went ashore on brief liberty conducted themselves appropriately and returned to the ship as scheduled. Officers who came ashore for official business or personal errands appeared professional and gave no indication of concerns about the upcoming voyage. The routine nature of these interactions suggested that the crew considered the port call and subsequent departure to be unremarkable events. The refueling operation that began on the afternoon of March 3rd continued through the evening and into the early morning hours of March 4th. Coal lighters positioned themselves alongside the USS Cyclops to transfer approximately 800 tons of coal to replenish the bunkers that had been depleted during the voyage from Bahia. The coal was loaded through side ports into the bunker spaces, with trimmers working to distribute the fuel evenly to maintain proper trim. The loading rate averaged approximately 100 tons per hour, requiring approximately 8 hours to complete the transfer of the required tonnage. Fresh water was transferred to the ship's potable water tanks to replenish supplies consumed during the 10-day passage from Bahia. The water capacity aboard the USS Cyclops was sufficient for the crew and passengers for approximately 2 weeks under normal consumption rates. The resupply in Barbados ensured adequate water for the estimated 7 to 8 day voyage to Baltimore, with reserves for contingencies. The water was pumped from shore storage tanks through hoses connected to the ship's deck fittings. Provisions loaded in Barbados included fresh fruits, vegetables, and meat to supplement the ship's stores of preserved and canned foods. The tropical climate of Barbados provided access to produce that was unavailable during the winter months in northern ports. The supply officer purchased these provisions from local merchants and had them delivered to the ship by boat. The addition of fresh food improved the quality of meals for the crew and passengers during the final segment of the voyage. The engineering department used the time in port to conduct maintenance on the operating port engine and associated machinery. Personnel cleaned and inspected engine components that were accessible without major disassembly. Lubrication points were serviced, and fluid levels in various systems were checked and topped off as necessary. The chief engineer supervised these activities personally, ensuring that the engine that would be relied upon for the voyage to Baltimore was in optimal condition. Captain Worley consulted with harbour officials about weather forecasts for the route from Barbados to Baltimore. The information available in March 1918 was based on reports from ships at sea and on meteorological observations at coastal stations. The forecast indicated generally favourable conditions, with no major storm systems predicted along the projected route. Wind patterns were expected to be moderate, with prevailing easterly trades that would create following seas for a vessel heading northwest toward the United States. Witnesses who observed the USS Cyclops during her time in Carlisle Bay noted no obvious signs of structural damage or unusual conditions beyond the heavy loading and single-engine operation. The ship's hull appeared sound, with no visible breaches or areas of concern. The rigging and deck equipment were properly secured for sea operations. The lifeboats were in their davits and appeared ready for deployment if needed. These observations suggested that the vessel was fit for the continuation of the voyage, despite operating with a reduced propulsion capability. The passenger complement remained stable during the Barbados stop, with no passengers disembarking and no additional civilians boarding. Consul General Gottschalk and his family remained in their accommodations aboard ship, as did the other passengers who had boarded in Rio de Janeiro. The ship's manifest for the departure from Barbados therefore remained at 309 people, identical to the count when the vessel had arrived from Bahia. Several crew members sent letters ashore to be posted through British colonial mail services. These letters were addressed to family members in the United States and described the voyage from Brazil and the brief stop in Barbados. The content of the letters reflected routine shipboard experiences, with no expressions of unusual concern about the ship's condition or the upcoming voyage. The writers anticipated arrival in Baltimore within approximately 1 week and made plans for activities during the expected Liberty period. The decision to depart Barbados on March 4th was based on the completion of refueling and resupply operations and on the weather forecast that indicated favourable conditions for the voyage to Baltimore. Captain Worley finalised the departure schedule after consulting with the executive officer and the chief engineer to verify that the ship was ready for sea. The harbour master was notified of the intended departure time, and British authorities were informed that the vessel would be leaving Barbadian waters. The USS Cyclops weighed anchor at approximately 2 p.m. local time on March 4, 1918, and proceeded out of Carlisle Bay under power from the port engine. The departure was observed by harbour officials and by crews of other vessels anchored in the bay. The ship's heading as she left the harbour was northwest, consistent with the intended route toward Baltimore. The speed through the water was estimated at approximately 8 to 10 knots based on the vessel's progress and the single propeller's thrust. Weather conditions at the time of departure were described as generally favourable, with scattered clouds and moderate winds from the east. Sea conditions in Carlisle Bay were calm, with light swells that would not impede the ship's departure. The barometric pressure was steady, indicating stable atmospheric conditions. Visibility was good, allowing clear observation of the ship as she proceeded seaward. The last confirmed visual sighting of the USS Cyclops came from the harbour master's office in Bridgetown, where personnel observed the vessel proceeding northwest from Carlisle Bay during the afternoon of March 4th. The ship was visible from shore stations for approximately 2 hours as she steamed away from Barbados at her reduced speed. The observers noted no unusual behaviour or circumstances as the vessel gradually disappeared over the horizon. The USS Cyclops maintained a steady course and appeared to be operating normally as she began the final segment of her voyage. British colonial authorities filed routine port departure reports documenting the USS Cyclops' visit to Barbados and her departure on March 4th. These reports included the vessel's name, nationality, cargo description, number of persons aboard, and intended destination. The documentation was transmitted to London through standard administrative channels and would later become part of the official record examined during the investigation into the ship's disappearance. The reports noted the vessel's mechanical condition and the fact that she was operating on a single engine, information that would prove significant when analysts attempted to determine what had happened to the ship. Radio communication capabilities aboard the USS Cyclops allowed the vessel to maintain contact with shore stations during the initial hours after departure from Barbados. The ship's wireless equipment had a range of approximately 100 to 150 nautical miles under favourable atmospheric conditions. Transmissions from the vessel would have been detectable by radio stations in Barbados and potentially by other stations in the Caribbean region as the ship proceeded northward. No distress signals or unusual communications were recorded by any station during the hours following the departure. The crew's preparations for the final leg of the voyage included securing all deck equipment and cargo hatches for extended sea operations. The deck department verified that the manganese ore cargo remained stable in the holds and that no shifting had occurred during the previous segments of the voyage. The engineering department confirmed that fuel and water supplies were adequate for the transit to Baltimore. The navigation department plotted the course that would take the ship through the waters between the Caribbean islands and the North American coast. Consul General Gottschalk and his family settled into their accommodations for the anticipated 7 to 8 day voyage to Baltimore. The consul's daughters wrote in their personal journals about the Barbados stop and expressed eagerness to arrive in the United States after the months-long journey from Rio de Janeiro. These journal entries, which would be lost with the ship, represented the final private thoughts of passengers who expected a routine completion to their travels. The distance from Barbados to Baltimore was approximately 1,700 nautical miles along the standard shipping route that followed established navigation lanes between the Caribbean and the North American coast. At the USS Cyclops' reduced speed of 8 to 10 knots, the voyage was calculated to require 7 to 8 days under normal conditions. This timeline placed the expected arrival in Baltimore between March 11th and March 13th, the dates when port authorities would be watching for the vessel. The USS Cyclops departed Barbados with adequate fuel, provisions, and water for the voyage ahead. The port engine was operating smoothly, and no mechanical problems had developed during the stop in Carlisle Bay. The crew was rested and prepared for sea operations. The weather forecast indicated favourable conditions. By all observable measures, the vessel appeared ready to complete the final segment of her mission. The ship steamed northwest from Barbados on the afternoon of March 4, 1918, and was never seen again. The standard navigation route from Barbados to Baltimore covered approximately 1,700 nautical miles, following established shipping lanes that had been used for decades by vessels transiting between the Caribbean and North American ports. The route required heading northwest from Barbados through the waters east of the Lesser Antilles, then continuing northward through the area between Bermuda and the North American coast before turning west toward the Chesapeake Bay entrance. This routing kept vessels in relatively deep water while maintaining reasonable distances from land for position-fixing purposes and emergency refuge if needed. Navigation procedures for this route in 1981 relied primarily on celestial observations using sextants to measure the angles of the sun, moon, and stars above the horizon. The navigator would take sights at dawn, noon, and dusk to establish lines of position that could be plotted on charts to determine the ship's location. Between celestial observations, the navigator used dead reckoning to estimate position based on the ship's course, speed, and the effects of wind and current. The accuracy of dead reckoning depended on the quality of the ship's compass, the helmsman's ability to maintain a steady heading, and the navigator's understanding of local oceanographic conditions. The geography of the region through which the USS Cyclops would transit included several significant features that affected navigation and safety. The Puerto Rico Trench, located approximately 500 miles northwest of Barbados, represented one of the deepest points in the Atlantic Ocean, with depths exceeding 28,000 feet. Ships passing over this area operated in waters too deep for anchoring or for salvage operations if a vessel sank. The Bermuda Islands, located approximately 900 miles north of Barbados, served as a major navigation reference point and offered port facilities for vessels requiring emergency assistance. The waters through which the USS Cyclops would travel would later become known as the Bermuda Triangle, though that term would not be coined until decades after 1918. The area bounded roughly by Bermuda, Florida, and Puerto Rico had long been noted by mariners as presenting navigation challenges due to unpredictable weather patterns, strong currents, and compass anomalies caused by variations in the Earth's magnetic field. The Gulf Stream current, flowing northward through this region at speeds of 2 to 4 knots, created complex sea conditions and affected vessel navigation by pushing ships off their intended courses. Weather patterns in the Western Atlantic during March typically featured the transition from winter to spring conditions, with cold fronts moving southward from North America, encountering warm, tropical air masses. These interactions could produce rapidly developing storm systems with high winds and rough seas. However, the period from March 4th through March 13th, 1918, showed no evidence of major storm activity along the route the USS Cyclops was expected to follow. Meteorological records from coastal stations and reports from ships at sea indicated generally moderate conditions, with no severe weather systems documented. The expected travel time for the USS Cyclops to complete the voyage from Barbados to Baltimore was calculated based on the ship's reduced speed capability while operating on a single engine. At 8 to 10 knots sustained speed, the 1,700 nautical mile distance would require between 170 and 213 hours of continuous steaming. This translated to approximately 7 to 9 days of transit time under normal conditions. Factors that could affect this timeline included weather conditions that might require speed reduction, mechanical problems that could further degrade performance, or navigation errors that might add distance to the voyage. Traffic in the shipping lanes between the Caribbean and North America was substantial during March 1918, with both military and commercial vessels operating in the area. American naval vessels patrolled the waters, watching for German submarines and escorting merchant convoys. British and Allied merchant ships transported cargo between South American ports and destinations in North America and Europe. The volume of shipping meant that vessels frequently sighted other ships during passages through this region. The USS Cyclops should have encountered or been observed by multiple other vessels during her transit northward from Barbados. Communication protocols for naval vessels in 1918 required regular position reports to be transmitted via radio to shore stations and to other naval vessels in the area. The standard procedure called for position reports at least once per day, with additional reports when passing significant navigation waypoints or when conditions changed. Shore-based radio stations maintained listening watches on frequencies used by naval vessels to ensure that communications could be received and relayed as necessary. The failure of a vessel to make scheduled radio contact would trigger inquiries and eventual search operations if the silence persisted. The radio equipment aboard the USS Cyclops consisted of spark gap wireless telegraph systems that generated radio frequency signals by creating electrical sparks across a gap between electrodes. This technology was standard for ship installations in 1918, but had significant limitations compared to modern radio systems. The transmission range depended on the power of the spark gap, the efficiency of the antenna system, and atmospheric conditions that affected radio wave propagation. Under optimal conditions, the USS Cyclops radio could transmit and receive signals at ranges exceeding 100 nautical miles, though atmospheric interference often reduced effective range substantially. Radio stations capable of communicating with ships in the Western Atlantic included facilities in Bermuda, Puerto Rico, Florida, and along the eastern seaboard of the United States. These stations maintained continuous listening watches and logged all communications with vessels in their coverage areas. The network of shore stations provided overlapping coverage that ensured ships transiting the route from Barbados to Baltimore would remain within radio range of at least one station throughout most of the voyage. Gaps in coverage existed in the deep ocean areas between station ranges, but these gaps typically lasted only a few hours as vessels moved from one coverage zone to another. The failure of the USS Cyclops to make any radio transmissions after departing Barbados represented a significant anomaly. Ships experiencing mechanical difficulties typically attempted to communicate their problems to shore stations or to other vessels, even if propulsion was lost. Radio equipment operated independently of the main engines, powered by batteries or by auxiliary generators that could function even if the ship's main electrical system failed. The complete radio silence suggested either that the radio equipment had failed simultaneously with other ship systems, or that the vessel had suffered a catastrophic event that prevented the crew from transmitting distress signals. Distress signal procedures in 1918 required ships in emergency situations to transmit the international distress call, which consisted of a series of dots and dashes in Morse code that spelled out SOS. Radio operators aboard ships maintained listening watches specifically to detect distress calls from other vessels. Shore stations also monitored distress frequencies continuously. The transmission of an SOS signal would trigger immediate response from any station or vessel receiving the call, with assistance rendered or rescue operations initiated based on the position and nature of the emergency reported. The absence of any SOS transmission from the USS Cyclops indicated that either the emergency developed too rapidly for the radio operator to reach his equipment and transmit, or that the ship's electrical systems failed before a distress call could be sent. Rapid sinking scenarios, such as might result from catastrophic structural failure or internal explosion, could prevent distress transmissions if the radio room became inaccessible or if the ship capsized before the operator could complete the transmission sequence. Gradual deterioration scenarios, such as might result from weather damage or progressive flooding, typically allowed time for distress communications unless electrical power was lost early in the emergency. Navigation hazards along the route from Barbados to Baltimore included shoals and reefs near the Caribbean islands, though the standard shipping route kept vessels in deep water well clear of these dangers. The continental shelf off the North American coast presented shoaling water that required careful navigation when approaching port, but this area would only be reached after the USS Cyclops had travelled more than 1,500 nautical miles from Barbados. Navigational errors would need to be substantial to cause a vessel following the standard route to encounter underwater obstacles capable of causing shipwreck. Ocean currents in the region could affect ship navigation and position, particularly for vessels with reduced speed capability, like the USS Cyclops, operating on a single engine. The North Equatorial Current flows westward across the Atlantic at latitudes south of Bermuda, creating a drift that could push ships to the west of their intended track. The Gulf Stream flows northward along the western edge of the Atlantic Basin, creating strong currents that could affect vessels approaching the North American coast. Navigators were aware of these current systems and made allowances in their course, planning to compensate for the effects of drift. The depth of water along most of the route exceeded 10,000 feet, placing the ocean floor far beyond the reach of any search or salvage equipment available in 1918. Ships that sank in these deep waters would come to rest on the abyssal plain, where they would be impossible to locate using the technology of that era. The extreme depth meant that wreckage, bodies, or debris from a sunken ship might never surface, particularly if the vessel sank intact rather than breaking apart on the surface. The ocean's depth in this region contributed to the complete absence of physical evidence following the USS Cyclops' disappearance. Atmospheric conditions that could affect radio communications included thunderstorms that generated electrical interference, ionospheric disturbances that altered radio wave propagation, and solar activity that created magnetic field variations. These natural phenomena were not well understood in 1918, and radio operators often attributed communication difficulties to equipment problems rather than environmental factors. However, atmospheric interference would typically create intermittent communication problems rather than complete and permanent radio silence. The absolute absence of any transmissions from the USS Cyclops after March 4th suggested something beyond ordinary communication difficulties. Other vessels transiting the same general area during the period between March 4th and March 13th, 1918, reported normal communications with shore stations and routine observations of weather and sea conditions. Merchant ships and naval vessels that should have been operating along similar routes made their scheduled position reports and arrived at their destinations without incident. The experiences of these other vessels indicated that the region was not experiencing unusual conditions that would affect all shipping in the area. The USS Cyclops encountered circumstances unique to her situation rather than environmental conditions that affected multiple vessels. The expected arrival date of March 11th to March 13th passed without any contact from the USS Cyclops. No radio transmission had been received. No visual sighting had been reported by other vessels. No evidence of the ship's passage had been detected by any means. The vessel had entered a void between Barbados and Baltimore, a span of ocean that should have been crossed in routine fashion, but which instead became the location of one of maritime history's most complete disappearances. The USS Cyclops had vanished as thoroughly as if she had never existed, leaving behind only the silence where her radio signals should have been heard, and the empty berth where she should have docked. On March 14, 1918, after the USS Cyclops failed to arrive in Baltimore by her expected date, the Navy Department initiated what would become one of the most extensive search operations in maritime history. The authorization for a comprehensive search came from the Office of the Chief of Naval Operations following notification from Baltimore port authorities that the vessel was now more than 24 hours overdue. The initial assumption was that mechanical difficulties had delayed the ship's arrival or forced her to divert to an alternate port. But the complete absence of radio communication suggested that circumstances might be more serious than a simple delay. The Navy Department issued orders to all Atlantic Fleet units to report any information regarding the USS Cyclops and to be prepared to participate in search operations if the vessel's location could not be determined through routine inquiries. Shore commands at naval stations from Florida to Maine were directed to contact their counterparts in the Coast Guard, and at commercial ports to inquire whether the missing collier had made an unscheduled stop for emergency repairs. The initial phase of the search involved confirming that the USS Cyclops had not simply arrived at a location other than her intended destination. By March 15th, when inquiries to all major Atlantic ports had produced negative results, the Navy Department escalated the search to include active operations at sea. Naval vessels operating in the Western Atlantic received orders to proceed to designated search areas along the route the USS Cyclops would have followed from Barbados to Baltimore. The search plan divided the probable track into sectors, with each sector assigned to specific ships or groups of ships. The vessels assigned to search duties included destroyers, patrol craft, Coast Guard cutters, and other auxiliaries that could be spared from their regular missions. The search sectors extended from the waters immediately north of Barbados through the Caribbean approaches, along the projected route toward Bermuda and into the waters off the North American coast. Each sector covered approximately 10,000 square miles of ocean, representing the area that the USS Cyclops might have drifted into if she had become disabled or had deviated from her planned route. The total search area encompassed more than 100,000 square miles of the Atlantic Ocean, an expanse that would require weeks to cover thoroughly, even with multiple vessels dedicated to the effort. USS Dixie, a destroyer tender operating near Bermuda, was among the first naval vessels to reach her assigned search sector. The ship began systematic patrol patterns on March 16th, with lookouts posted to scan the horizon for any sign of the missing collier. The search procedures involve steaming along predetermined courses at moderate speed while maintaining visual surveillance of the surrounding waters. Lookouts used binoculars to search for wreckage, lifeboats, or any floating debris that might indicate where a ship had sunk. Coast Guard cutters Tampa, Manning, and Seneca joined the search operation on March 17th after being released from convoy escort duties. These vessels were equipped for search and rescue operations, carrying boats that could be launched to investigate debris or to approach shallow areas where wreckage might have washed ashore. The Coast Guard crews were experienced in conducting searches for missing vessels and brought expertise in interpreting ocean currents and drift patterns that could help locate evidence of a shipwreck. Search aircraft from naval air stations in Florida and Virginia flew reconnaissance missions over portions of the search area when weather permitted. The aircraft available in 1918 had limited range and endurance, restricting their search operations to coastal waters within approximately 100 miles of their bases. The aircrews searched for oil slicks, floating wreckage, or any surface disturbance that might indicate the location of a sunken ship. The aerial perspective allowed observers to cover larger areas more quickly than surface vessels, though the aircraft could only operate during daylight hours and in favourable weather conditions. Merchant vessels transiting the region received notices requesting that they report any observations of wreckage or debris that might be related to the USS Cyclops. The notices were transmitted by radio and were posted at ports throughout the Caribbean and along the Atlantic coast. Several merchant captains reported sighting floating objects during the days following the search notification, but investigation of these reports revealed only routine maritime debris or natural flotsam unrelated to the missing naval vessel. The British colonial government in Bermuda contributed vessels from the local marine police and harbour patrol to search waters around the island. These small craft were familiar with the reefs and shoals around Bermuda and could investigate areas that were inaccessible to larger naval vessels. The Bermuda authorities also organised shore patrols to search beaches and rocky coastlines where wreckage might have washed ashore. These efforts continued for several weeks but discovered no evidence related to the USS Cyclops. Search vessels maintained regular radio communication with coordination centres established at naval stations in Puerto Rico, Bermuda, and Norfolk. Each searching ship reported its position, the areas covered, and any observations made during patrol operations. The coordination centres compiled these reports to track search progress and to identify areas that required additional coverage. The reporting system ensured that search efforts were not duplicated and that all portions of the designated search area received adequate attention. Oceanographic analysis conducted by Navy hydrographers attempted to predict where debris from the USS Cyclops might drift if the ship had sunk in various locations along her projected route. The analysis considered prevailing currents, including the Gulf Stream, and various local circulation patterns, as well as wind conditions during the period when the ship would have been transiting from Barbados to Baltimore. The drift predictions suggested that floating debris from a ship lost anywhere along the route should have surfaced and should have been carried by currents toward the North American coast or toward the Caribbean islands. Despite the predictions that debris should have been detectable, search operations discovered no wreckage, no oil slicks, no lifeboats, and no bodies. The negative results persisted as the search extended through late March and into early April. Vessels that had been assigned to search duties for more than 2 weeks without finding any evidence began to be released to return to their regular missions. The Navy Department gradually scaled back the active search while maintaining general alerts, requesting that all vessels continue to report any observations that might be related to the missing ship. The search for the USS Cyclops represented one of the most thorough maritime search operations conducted up to that time. The combination of surface vessels, aircraft, shore patrols, and cooperation from merchant shipping created a comprehensive effort that should have located wreckage, if any existed on the ocean surface or along coastlines. The technology available in 1918 was limited compared to modern search capabilities, but visual observation from ships and aircraft remained effective methods for locating floating debris or signs of shipwreck. Communications with foreign governments requested information about whether the USS Cyclops might have been sighted in waters outside the primary search area. The British Admiralty was contacted regarding possible sightings in the Eastern Atlantic or in European waters. Latin American nations with Atlantic coastlines were asked to report any wreckage or debris that might have drifted to their shores. These inquiries produced no relevant information. The USS Cyclops had not been observed anywhere outside the area between Barbados and Baltimore, where she was expected to transit. The Coast Guard maintained patrols along the Atlantic seaboard, specifically watching for evidence of the USS Cyclops throughout the spring of 1918. Beachwalkers and lighthouse keepers were asked to report any unusual debris or wreckage that washed ashore. Fishermen operating offshore were requested to note any observations of floating objects that might be related to the missing vessel. These ongoing surveillance efforts continued for months after the active search was suspended, but they produced no evidence of the ship's fate. Navy divers were not employed in the search operation because the depth of water along the USS Cyclops' probable route exceeded the maximum diving depth achievable with the equipment available in 1918. Standard diving dress allowed operations to depths of approximately 200 feet under favourable conditions, far less than the thousands of feet of water depth that characterised most of the search area. The absence of shallow water locations where the ship might have sunk eliminated diving as a search method. Submarine detection equipment, which was being developed during World War I for locating German U-boats, was not applicable to searching for a sunken surface ship. The listening devices used for submarine detection could only detect sounds generated by operating machinery and were ineffective for locating stationary wreckage on the ocean floor. The technology for acoustic depth sounding was in its infancy and was not deployed operationally on most naval vessels in 1918. The failure to locate any trace of the USS Cyclops, despite the extensive search effort, led to speculation about whether the ship had sunk in a location outside the expected search area. Some investigators suggested that navigation errors might have caused the ship to travel far off course, placing her final position in waters that were not included in the search sectors. This theory required assuming substantial navigational incompetence or compass failure, circumstances that were possible, but which contradicted the known experience and qualifications of the ship's navigator and commanding officer. Weather records for the period between March 4th and March 13th were examined to determine whether storm conditions might have overwhelmed the USS Cyclops in a location where the search failed to find evidence. The meteorological data showed no severe storms along the projected route during this time frame. Several moderate weather systems had moved through the region, producing winds of 25 to 35 knots and seas of 10 to 15 feet, but these conditions were well within the capability of a vessel like the USS Cyclops to navigate safely even with reduced propulsion. On April 17, 1918, more than 6 weeks after the USS Cyclops was last seen departing Barbados, the Navy Department officially suspended active search operations. The announcement acknowledged that the vessel was presumed lost with all hands, but noted that the cause and location of the loss remained undetermined. Ships and aircraft were released from search duties to resume their regular wartime missions. The search for the USS Cyclops had consumed thousands of ship hours and flight hours without producing a single piece of evidence about what had happened to the vessel or where she had met her fate. The total area covered by search vessels exceeded 250,000 square miles of ocean when accounting for the expanded search zones that were added as the operation progressed. Dozens of ships and aircraft had participated in the effort, conducting systematic searches of waters from the Caribbean to the mid-Atlantic coast. Shore patrols had walked hundreds of miles of coastline searching for wreckage. The comprehensiveness of the search effort made the complete absence of findings even more remarkable and more difficult to explain through conventional maritime casualty scenarios. The Naval Court of Inquiry into the loss of the USS Cyclops convened on June 12, 1918, at the Navy Department building in Washington, District of Columbia. The court was charged with investigating the circumstances surrounding the disappearance of the vessel and determining, if possible, the cause of the loss and whether any personnel had been negligent or culpable in contributing to the disaster. The inquiry was conducted under the authority of naval regulations governing investigations into ship losses and casualties, with the court empowered to compel testimony from witnesses and to examine all relevant documents and physical evidence. The court consisted of 3 senior naval officers appointed by the Secretary of the Navy. Captain William Rush presided over the proceedings, with Commander Harold Jensen and Commander Robert Plunkett serving as additional members. A judge advocate, Lieutenant Commander Thomas Withers, was assigned to present evidence and to conduct examination of witnesses. The court convened in closed session due to wartime security concerns and the potential that evidence might reveal information useful to enemy forces. The investigation timeline extended from June 1918 through March 1919, with testimony taken from dozens of witnesses and hundreds of documents examined. The court held formal sessions on multiple dates, with recesses between sessions to allow for additional evidence gathering and for the preparation of witness testimony. The extended duration of the inquiry reflected both the complexity of the case and the difficulty of obtaining information about a ship that had vanished without leaving physical evidence. Witnesses called to testify before the court included naval personnel who had served aboard the USS Cyclops during previous voyages, officers from other ships who had observed the vessel in various ports, maintenance personnel from naval shipyards who had conducted inspections and repairs, and civilians who had interacted with the ship or her crew. The British consul from Barbados, B.S. Mayers, provided written testimony describing his observations of the vessel during her final port call. Brazilian port officials submitted reports about the cargo loading operations in Rio de Janeiro. The testimony of crew members who had served aboard the USS Cyclops, but who were not present during the final voyage, provided insights into the ship's condition and operational practices. Former crew members described the vessel's structural problems, including the engine bed cracks that had been documented during inspections. Several witnesses testified about the ship's tendency to roll heavily in moderate seas, suggesting potential stability concerns. Engineering personnel discussed the challenges of maintaining the aging propulsion machinery and the frequency of mechanical failures that had required repairs during the ship's operational history. Officers who had served under Captain Worley provided assessments of his command style and competence. The testimony regarding Worley was mixed, with some officers praising his professional knowledge, while others criticised his eccentric behaviour and occasionally arbitrary decisions. The court examined Worley's service record, including fitness reports prepared by superior officers during his years commanding the USS Cyclops. The record showed generally satisfactory performance ratings with no major disciplinary incidents or professional failures documented. The court examined maintenance logs and inspection reports from the USS Cyclops, covering the period from 1916 through early 1918. These documents revealed a pattern of recurring mechanical problems and structural deterioration that had required frequent repairs. The 1917 structural survey that had identified cracks in the engine bed castings received particular attention, as did the decision to defer repairs due to operational requirements. Navy shipyard personnel testified about the extent of the structural problems and the potential risks of operating the vessel without completing the recommended repairs. Engineering experts were called to provide technical analysis of the ship's propulsion system and the implications of operating on a single engine. The experts explained that while single-engine operation was technically feasible, it created unusual stress patterns in the hull structure and reduced the vessel's ability to maintain course in heavy seas. The asymmetric thrust from one propeller required constant helm correction, and the reduced speed made the ship more vulnerable to weather conditions that a fully powered vessel could navigate safely. Cargo loading procedures and the characteristics of manganese ore received extensive examination during the inquiry. Naval architects testified about the stability implications of loading dense cargo in holds designed for coal. The experts explained the physics of free surface effect and the dangers of cargo shifting in rough seas. Calculations were presented showing that the USS Cyclops, when loaded with 10,800 tons of manganese ore, would have had substantially different stability characteristics compared to her normal coal cargo configuration. The court reviewed weather records for the period from March 4 through March 13, 1918, examining meteorological data from coastal stations and from ships operating in the Western Atlantic. The evidence showed moderate weather conditions with no severe storms documented along the route the USS Cyclops should have followed. Several witnesses testified about weather systems that had passed through the region during this period, but none described conditions that would be considered dangerous for a vessel of the Cyclops' size and capability under normal circumstances. Radio communication records from shore stations in Barbados, Bermuda, Puerto Rico, and along the Atlantic coast were examined to verify that no transmissions had been received from the USS Cyclops after her departure from Barbados. The court reviewed procedures for radio watchkeeping and distress signal protocols to determine whether any possibility existed that transmissions from the ship had been made but not recorded. The evidence conclusively showed that the vessel had maintained complete radio silence from the moment of departure until she was declared missing. The investigation considered multiple possible causes for the ship's loss. Structural failure represented one category of explanation, with the known cracks in the engine bed castings and the general deterioration of the hull potentially leading to catastrophic breakdown at sea. Expert witnesses testified that sudden structural failure could cause a ship to break apart and sink rapidly, potentially without time for the crew to transmit distress signals or abandon ship. Weather-related causes were examined, despite the absence of documented severe storms along the projected route. The court considered whether localized weather phenomena, such as waterspouts or rogue waves, might have overwhelmed the vessel. Oceanographers testified about the possibility of encountering extreme sea conditions that were not recorded by coastal weather stations. However, the probability of such conditions occurring during the specific time frame and location remains speculative, without supporting evidence. The possibility that cargo shifting had caused the USS Cyclops to capsize received detailed analysis. Naval architects calculated the stability of the vessel under various cargo distribution scenarios and examined how ore cargo might shift during heavy rolling. The testimony indicated that improperly distributed ore cargo could create conditions where a ship might capsize suddenly if the cargo mass moved to one side. The absence of any distress transmission would be consistent with a rapid capsizing that gave the crew no time to reach radio equipment. Enemy action was investigated as a potential cause, given the wartime context and the presence of German submarines. In the Atlantic during March 1918, the court examined intelligence reports about U-boat operations and reviewed German naval communications that had been intercepted by Allied forces. The evidence showed no German submarine activity in the immediate area where the USS Cyclops was expected to have been operating. Post-war examination of German naval records would later confirm that no U-boat had claimed the vessel as a victory. Captain Worley's German birth and his potential loyalty to the United States received examination by the court. Investigators reviewed Worley's background, naturalization records, and personal correspondence to determine whether any evidence existed suggesting sabotage or deliberate scuttling of the vessel. The investigation found no indication of divided loyalty or suspicious behaviour. Worley's service record showed consistent dedication to his duties and no connections to German nationals or organisations that might have influenced his actions. The mechanical condition of the starboard engine and the decision to proceed with only the port engine operational were scrutinised to determine whether this represented negligent risk-taking. Expert witnesses testified that single-engine operation was within acceptable parameters for a collier making a coastal passage with opportunities to divert to intermediate ports if problems developed. The court found that Captain Worley's decision to proceed from Rio de Janeiro without repairing the starboard engine, while involving elevated risk, did not constitute negligence, given wartime operational demands. The investigation examined whether the USS Cyclops might have deviated from her intended route and sunk in a location outside the areas covered by search operations. Navigation experts testified about the accuracy achievable with celestial navigation and dead reckoning techniques. The testimony indicated that substantial navigation errors would be required to place the ship far enough off course to avoid the search areas. The court found no evidence suggesting gross navigation incompetence or compass failure that would lead to such errors. The possibility that the USS Cyclops had been captured by German forces and taken to an enemy port was considered but found unlikely. The logistics of capturing a 19-housing 360-ton collier with 309 people aboard and transporting it across the Atlantic without detection were beyond the capabilities available to German naval forces in 1918. The absence of any reports of such a capture in German records examined after the war confirmed that this scenario had not occurred. The court's findings, documented in a report submitted to the Secretary of the Navy on March 31, 1919, concluded that the USS Cyclops had been lost at sea between March 4 and March 13, 1918, with all 309 persons aboard. The report stated that the exact cause of the loss could not be determined based on available evidence. The court found no evidence of negligence or culpability on the part of any Navy personnel in connection with the loss. The report noted that the ship's structural condition and the nature of her cargo may have contributed to the casualty, but that definitive conclusions could not be reached without physical evidence. The recommendations section of the report called for improved inspection procedures for aging auxiliary vessels and for more rigorous analysis of cargo loading practices when ships designed for one type of cargo were adapted to carry different materials. The court recommended that vessels showing significant structural deterioration should be retired from service or subjected to major overhaul rather than continuing in operation with deferred maintenance. These recommendations influenced Navy policies regarding auxiliary vessel management in subsequent years. The classification of the USS Cyclops' loss as cause undetermined reflected the fundamental problem faced by the investigation. Without wreckage, bodies, or any physical evidence, the court could not establish with certainty what had happened to the vessel. The multiple theories examined during the inquiry each explained certain aspects of the disappearance, but none could be proven or disproven without evidence. The investigation demonstrated the limitations of maritime casualty investigation when a vessel vanished completely without leaving any trace. The families of the 309 people lost with the USS Cyclops received notification of the court's findings and the official determination that their loved ones had perished at sea. The lack of definitive answers about what had caused the ship to sink provided little comfort to those who had lost family members. Compensation claims filed by families and by dependents of crew members were processed through standard Navy channels, with payments made based on the official determination of death, despite the absence of bodies or other conclusive evidence of the disaster. Several theories emerged to explain the USS Cyclops' disappearance, each supported by different aspects of the available evidence and the ship's known condition. Maritime experts, naval investigators, and subsequent researchers examined the circumstances of the loss and proposed explanations that ranged from mechanical failure to environmental catastrophe. The absence of physical evidence meant that none of these theories could be definitively proven, but each offered a plausible scenario consistent with certain facts about the ship and her final voyage. The structural failure theory proposed that the USS Cyclops suffered catastrophic breakdown of her hull or keel while at sea, causing the vessel to break apart and sink rapidly. This explanation drew support from the documented structural problems identified during the 1917 inspection at Norfolk Navy Yard. The cracks in the engine bed castings indicated that the ship's structure was experiencing stress beyond design limits. Naval architects who examined the evidence noted that engine bed failure could lead to shaft misalignment, which might damage the stern tube and create a pathway for catastrophic flooding. The structural failure scenario suggested that the combination of the ship's age, the deferred maintenance, and the unusual stress imposed by the dense manganese ore cargo created conditions where the hull could fracture suddenly. The concentration of 10,800 tons of ore in the lower portions of the cargo holds placed enormous stress on the bottom plating and keel structure. Dynamic loads from wave action would amplify these stresses, particularly if the ship encountered rough seas. A crack developing in the keel or bottom plating could propagate rapidly through the hull structure, causing the ship to break in half and sink within minutes. Supporting evidence for structural failure included the ship's known maintenance problems and the pattern of deterioration documented in inspection reports. The USS Cyclops had been in continuous service since 1910, operating in demanding conditions that accelerated wear on structural components. Riveted construction was susceptible to fatigue cracks developing at rivet holes and along seams where plates joined. The adaptation of the vessel from coal transport to ore carrying imposed loads that exceeded the original design parameters. However, the structural failure theory faced significant problems explaining certain aspects of the disappearance. Ships that break apart on the surface typically create substantial debris fields, with wreckage, cargo, and buoyant materials floating free as the hull sections sink. The USS Cyclops carried wooden lifeboats, lumber for cargo dunnage, cork life preservers, and numerous other items that should have floated even if the ship herself sank rapidly. The complete absence of any floating debris suggested either that the ship sank intact rather than breaking apart, or that the structural failure occurred in such deep water that debris never reached the surface. The severe weather theory proposed that the USS Cyclops encountered storm conditions more extreme than those documented by coastal weather stations and was overwhelmed by heavy seas. This explanation acknowledged that weather observation in 1918 was limited to reports from ships at sea and from land-based stations, leaving large areas of ocean where conditions might differ substantially from recorded data. A ship operating on a single engine would have reduced maneuverability and might be unable to avoid dangerous weather systems that a fully powered vessel could navigate around. The mechanics of weather-related sinking involve several possible sequences. Heavy seas could cause the vessel to pitch violently, driving the bow underwater and causing progressive flooding through hatches or ventilators. Rolling in beam seas could allow water to enter through side openings, or could cause cargo to shift, leading to capsize. Extreme wave events, sometimes called rogue waves, could strike the ship with force sufficient to damage superstructure or to cause immediate flooding through breached hull plating. Evidence supporting the weather theory included the known vulnerability of colliers to heavy weather due to their relatively low freeboard when fully loaded. The USS Cyclops, carrying 10,800 tons of ore, would have been riding deep in the water with limited reserve buoyancy. Weather modelling studies conducted decades after the disappearance suggested that localised storm systems could develop in the region without being detected by the limited weather observation network of 1918. Ocean areas between weather reporting stations might experience conditions substantially different from those recorded at the stations. The problems with the weather theory centred on the lack of documented severe weather during the relevant time frame. No ships operating in the general area between Barbados and Baltimore during early March 1918 reported encountering dangerous storm conditions. The absence of distress signals from the USS Cyclops suggested that if weather was a factor, the vessel must have been overwhelmed so quickly that the radio operator had no opportunity to transmit. This rapid overwhelming would require either a rogue wave strike or a sudden capsizing, events that typically occur in already rough seas rather than in the moderate conditions documented for the period. The cargo shift theory proposed that the manganese ore loaded in the USS Cyclops holds moved during heavy rolling, creating a list that progressed to capsizing. This explanation focused on the specific characteristics of bulk or cargo and the dangers of free surface effect in partially filled or improperly secured holds. Dense ore settling in the bottom of holds could create void spaces above the cargo surface, allowing the material to shift horizontally when the ship rolled. Once cargo began shifting to one side, the resulting list would cause additional cargo to slide in the same direction, accelerating the capsize. The physics of cargo-induced capsizing involves the interaction between the ship's center of gravity, the metacentric height, and the shifting weight of cargo. Naval architects calculated that ore cargo shifting by as little as 5 to 10 feet horizontally could create sufficient list to make recovery impossible. The ship would roll to the side where cargo had shifted, and the increasing angle would cause more cargo to slide, creating a self-reinforcing cycle ending in capsize. The entire sequence could occur within minutes, leaving no time for distress signals or for launching lifeboats. Supporting evidence for the cargo shift theory included the known behaviour of bulk ore in ships' holds and numerous historical precedents of vessels lost due to cargo shifting. Ore carriers and bulk cargo ships had capsized repeatedly throughout maritime history when cargo moved during heavy seas. The USS Cyclops was not specifically designed for ore transports, and her hold configuration may have been inadequate for preventing ore movement. The loading procedures in Rio de Janeiro may not have included proper measures to secure the cargo or to prevent void spaces from forming as the ore settled during the voyage. The cargo shift theory explains several puzzling aspects of the disappearance. Rapid capsizing would prevent distress signals and would give the crew no opportunity to abandon ship or to take actions that might leave evidence of their plight. A capsized vessel might sink without breaking apart, taking all debris and buoyant materials with it to the bottom. The ore cargo itself would ensure that the ship sank rapidly once capsized, as the 10,800 tons of dense material would pull the inverted hull down quickly. Challenges to the cargo shift theory included questions about whether the cargo had been properly loaded and secured. Port officials in Rio de Janeiro reported that loading procedures followed standard practices, though the standards for ore loading in 1918 were less rigorous than modern requirements. The ship's cargo officer would have been responsible for ensuring proper distribution and securing of cargo, and nothing in his record suggested incompetence or negligence in these duties. The moderate sea conditions documented for the period seemed insufficient to cause the heavy rolling that would be needed to initiate cargo shifting. Comparative analysis of the three primary theories showed that each explained certain evidence while leaving other aspects unaccounted for. Structural failure explained the ship's known maintenance problems, but not the absence of debris. Severe weather explained the potential for rapid sinking, but contradicted the documented meteorological conditions. Cargo shifting explained the lack of distress signals and the complete disappearance, but required assumptions about improper cargo handling that were not clearly supported by evidence. Modern engineering analysis using computer modelling and advanced understanding of ship stability has provided additional insights into the theories. Simulations of structural failure scenarios have shown that certain types of keel fractures could cause a ship to sink rapidly enough to trap most debris inside the hull. Weather modelling has identified that atmospheric conditions can create localized severe weather that escapes detection by sparse observation networks. Cargo shift simulations have demonstrated that ore cargo can behave in unexpected ways, liquefying under certain conditions or shifting suddenly when disturbance exceeds threshold levels. The possibility that multiple factors combine to cause the loss represents a more complex theory that has gained support among researchers examining the case decades after the event. A ship with structural problems operating on reduced power while carrying unstable cargo through marginal weather might suffer a cascade of failures that individually would not be catastrophic but, in combination, prove fatal. The cracked engine beds might fail during heavy rolling induced by weather, leading to flooding that destabilizes the cargo, which shifts and causes capsize before the crew can respond. Expert assessments conducted by marine casualty investigators in subsequent decades have generally concluded that the most likely explanation involves cargo shift, possibly triggered or accelerated by structural problems or weather conditions. The combination of dense ore cargo improperly secured in holds designed for coal, structural deterioration from years of service, reduced propulsion capability, and the ship's operational circumstances created a situation where small margins for error existed. Once a destabilizing event began, whether from cargo movement, structural failure, or weather impact, the vessel had limited ability to recover before sinking. The enduring uncertainty about the exact cause of the USS Cyclops' loss reflects the fundamental limitation that physical evidence provides the only definitive basis for determining what happened to a lost ship. Theories based on analysis of circumstances and known conditions can propose plausible explanations, but without wreckage to examine or survivors to interview, the theories remain speculation, regardless of how well reasoned or technically supported they may be. The USS Cyclops vanished into a category of maritime mysteries where multiple explanations remain possible and where the truth may never be known with certainty. The timing of the USS Cyclops' disappearance in March 1918 occurred during the height of German U-boat operations in the Atlantic, leading to immediate speculation that the ship had been attacked and sunk by enemy action. The first 3 months of 1918 represented one of the most aggressive periods of German submarine warfare, with U-boats operating extensively in American coastal waters and along shipping routes between North and South America. The strategic importance of the manganese ore cargo aboard the USS Cyclops made the vessel a legitimate military target under the rules of unrestricted submarine warfare that Germany had resumed in February 1917. German naval strategy in early 1918 focused on interdicting Allied supply lines by sinking merchant vessels and naval auxiliaries carrying strategic materials. The submarine campaign aimed to starve Britain of resources and to prevent American industrial capacity from supporting the Allied war effort. Manganese ore, essential for steel production, represented exactly the type of cargo that German military planners sought to prevent from reaching American ports. A collier carrying 10,800 tons of high-grade manganese would have been considered a high-value target worthy of torpedo expenditure. The German U-boat fleet operating in the Atlantic during March 1918 included approximately 12 to 15 submarines deployed at various positions between the European coast and North American waters. These submarines were primarily Type U-151 and Type U-139 boats, large cruiser submarines with extended range capability that allowed them to operate far from their bases in Germany. The boats carried deck guns and torpedoes and were equipped to remain at sea for weeks at a time, conducting patrols across thousands of miles of ocean. Intelligence reports available to American naval authorities in March 1918 indicated that German submarines had been detected in the Western Atlantic during the preceding months. Several merchant ships had been sunk by U-boat action off the American coast during January and February 1918, confirming that German submarines were operating in the area. The US Navy maintained anti-submarine patrols and had established convoy systems to protect merchant shipping, but the vast expanse of ocean made it impossible to eliminate the U-boat threat entirely. The method by which German submarines typically attacked targets involved either torpedo launch from submerged position or surface gun action after stopping the target vessel. Torpedo attacks occurred without warning and could sink a ship within minutes if the torpedo struck in a critical location. Surface gun attacks required the U-boat to approach close to the target and to engage in what amounted to an artillery duel, though merchant vessels and auxiliaries were generally outgunned by submarine deck weapons. Naval regulations required submarines to allow crews to abandon ship before sinking merchant vessels. But military targets like the USS Cyclops could be attacked without warning under the rules of unrestricted warfare. The capability of German submarines to sink a vessel without leaving evidence depended on several factors. A torpedo strike that caused catastrophic hull breach could sink a ship rapidly, potentially before the crew could launch lifeboats or transmit distress signals. However, torpedoed ships typically left debris fields and oil slicks that persisted for hours or days after sinking. The explosive detonation of a torpedo warhead would create wreckage fragments that would float to the surface even if the ship herself sank quickly. The absence of any such debris following the USS Cyclops' disappearance suggested either that no torpedo attack occurred or that the attack happened in circumstances that prevented normal debris formation. Naval intelligence analysts examined reports of U-boat positions during early March 1918 to determine whether any German submarines were operating in the area where the USS Cyclops would have been transiting from Barbados to Baltimore. The analysis involved radio direction finding data, reports from merchant ships that had sighted or been approached by submarines, and intelligence derived from intercepted German naval communications. The assessment concluded that no German submarines were documented in the immediate vicinity of the USS Cyclops' projected route during the relevant time frame. The nearest documented U-boat presence to the USS Cyclops' probable position occurred more than 800 miles to the east, where U-151 had been operating in the mid-Atlantic. This distance placed the submarine too far from the collier's route to have intercepted the vessel, unless the USS Cyclops had deviated substantially from her intended course. Other German submarines operating in American waters during March 1918 were positioned off the northeastern United States coast or near the Caribbean islands, locations that were not directly on the route from Barbados to Baltimore. Captain Worley's German berth and his command of the USS Cyclops during wartime created circumstances that invited speculation about possible sabotage or deliberate scuttling. The theory that Worley might have intentionally caused the ship's loss as an act of sabotage on behalf of Germany emerged almost immediately after the disappearance became known. Proponents of this theory pointed to Worley's origins, his German name at birth, and his access to command authority that would allow him to navigate the ship to a predetermined location where German forces could capture or destroy her. Investigation of the sabotage theory involved examining Worley's background, his communications, and his behaviour for any indication of pro-German sympathies or suspicious activities. Naval intelligence reviewed Worley's personal correspondence, interviewed people who knew him, and analysed his service record for any evidence of divided loyalty. The investigation found no indication that Worley maintained contact with German nationals or organisations after immigrating to the United States. His naturalisation as an American citizen had been completed decades before World War I, and his service in the US Merchant Marine and Navy showed consistent loyalty to his adopted country. The logistics of deliberately scuttling the USS Cyclops or delivering her to German forces presented substantial practical difficulties that argued against the sabotage theory. Scuttling a ship at sea while ensuring that the crew perished without leaving survivors or evidence would require extraordinary planning and ruthless execution. Worley would need to prevent 308 other people aboard from escaping or from sending distress signals, a task that seemed nearly impossible without the cooperation of other crew members. No evidence suggested that any crew members were involved in sabotage or that Worley had recruited accomplices. The possibility that the USS Cyclops had been captured by German forces and taken to a European port was examined as an alternative to the sinking theory. This scenario required assuming that a German submarine or surface raider had intercepted the collier, forced the crew to surrender, and then sailed the captured vessel across the Atlantic. The practical problems with this theory were substantial. A 9-TOW 360-ton collier operating on a single engine would require several weeks to cross the Atlantic, during which time the captured vessel would be vulnerable to detection by Allied naval forces and merchant ships. German naval records examined after World War I provided crucial evidence regarding the U-boat theory. Allied forces captured extensive German military documents following the armistice in November 1918, including submarine patrol logs, command reports, and communications between U-boats and naval headquarters. Analysis of these documents showed no mention of any encounter with or attack on the USS Cyclops. No German submarine commander claimed credit for sinking an American naval collier during March 1918. The absence of any reference to the USS Cyclops in German records strongly suggested that German forces had not been involved in the ship's disappearance. Individual U-boat patrol logs from submarines operating in the Atlantic during March 1918 documented their positions, targets engaged, and ammunition expended. These logs were maintained for operational planning and supply purposes, and they provided detailed accounts of each submarine's activities during patrol periods. None of the logs showed any submarine in the position where the USS Cyclops would have been transiting between March 4th and March 13th. The submarines that were operating in American waters during this period were documented as being hundreds of miles away from the collier's probable route. The strategic value of capturing or sinking the USS Cyclops would have made such an accomplishment noteworthy in German naval circles. Submarine commanders received recognition and awards for successful attacks on enemy shipping, particularly for sinking large vessels or those carrying strategic cargo. The loss of an American naval vessel with 309 people aboard and a valuable manganese ore cargo would have been considered a significant victory worthy of documentation and publicity. The complete absence of any German claims regarding the USS Cyclops indicated that German forces were not responsible for the loss. Post-war interrogation of German submarine commanders and naval officers provided additional opportunities to inquire about the USS Cyclops. Allied intelligence officers questioned German personnel about operations in American waters and about any encounters with American naval vessels. None of the interrogations produced information suggesting that German forces had been involved with the missing collier. Former U-boat commanders who had operated in the Atlantic during 1918 stated that they had no knowledge of any German action against a vessel matching the USS Cyclops description. The wartime atmosphere of 1918 created conditions where enemy action was the default explanation for any unexplained ship loss. The public and many naval personnel assumed that German submarines were responsible for most maritime casualties during the war years. This assumption was reinforced by the documented sinking of numerous ships by U-boat action and by the general awareness that German submarines operated throughout the Atlantic. The USS Cyclops' disappearance occurred within this context, where suspicion of enemy involvement was natural and widely held. The investigation into German submarine involvement with the USS Cyclops loss continued sporadically for years after World War I ended. Researchers examined newly available German documents as archives were opened and as former military personnel provided additional information. The consistent finding across all sources was that no evidence connected German forces to the disappearance. The U-boat theory, while initially plausible, given the wartime context, could not be sustained when examined against the documentary record of German naval operations. The failure to find German involvement redirected attention to the other theories about structural failure, severe weather, and cargo shifting. The elimination of enemy action as an explanation meant that the USS Cyclops had been lost due to some combination of the ship's condition, the cargo characteristics, the operational circumstances, and potentially environmental factors. The absence of a foreign threat made the mystery more puzzling rather than less, as it meant that the vessel had been destroyed by natural or mechanical causes that left no trace. In 1941, 23 years after the USS Cyclops vanished, her two sister ships, the USS Proteus and USS Nereus, disappeared within weeks of each other while carrying ore cargoes. Both vanished without a trace in the same Atlantic waters. The pattern of losses would create an unprecedented record in naval history, an entire class of ships disappearing under nearly identical circumstances. The USS Proteus, designated AC-9, had been built at the same shipyard as the USS Cyclops, launched in 1912 and commissioned in 1913. She shared the identical Proteus-class design specifications: 542 feet in length, 65 feet beam, 9,360 tons displacement when fully loaded. The ship had survived World War I and continued operating as a naval collier through the interwar period. By 1941, the Proteus was 28 years old, her hull and machinery showing the accumulated wear of nearly 3 decades of continuous service. On November 23, 1941, the USS Proteus departed St. Thomas in the Virgin Islands bound for Portland, Maine, carrying a cargo of bauxite ore. Bauxite, the primary ore of aluminum, was essential for aircraft production and had become critically important as American industry mobilized for potential entry into World War II. The cargo weighed approximately 9,000 tons, slightly less than the manganese ore load that the USS Cyclops had carried in 1918, but still representing a dense cargo that created stability concerns similar to those that may have affected her sister ship. The crew and passenger complement aboard the USS Proteus totaled 58 people. The ship was commanded by Lieutenant Commander J.S.W. Wynne, an experienced officer who had been with the vessel for several years. The relatively small crew reflected the reduced manning requirements for auxiliary vessels during peacetime operations. Though the United States was on the verge of entering World War II following the attack on Pearl Harbor that would occur 2 weeks after the Proteus disappeared. The USS Proteus was never seen again after departing St. Thomas. No distress signal was received. No wreckage was found. No bodies were recovered. The ship simply vanished during the voyage from the Virgin Islands to Maine, disappearing somewhere along a route that would have taken her through waters near where the USS Cyclops had been lost 23 years earlier. The Navy declared the vessel missing on December 10th, 1941, 3 days after the Pearl Harbor attack focused national attention on the Pacific theater rather than on a missing auxiliary vessel in the Atlantic. The USS Nereus, designated AC-10, was the third and final ship of the Proteus class. Built at the same Philadelphia shipyard, launched in 1913 and commissioned in 1914, she was identical in design to her sister ships. The Nereus had served throughout World War I without incident and had continued operations through the 1920s and 1930s. By December 1941, she was 27 years old and showing the structural deterioration typical of colliers that had spent decades carrying heavy cargoes in demanding sea conditions. On December 10, 1941, the same day the USS Proteus was officially declared missing, the USS Nereus departed St. Thomas for Portland, Maine. She carried approximately 9,000 tons of bauxite ore, identical to the cargo that her sister ship had been transporting when she disappeared 3 weeks earlier. The crew and passengers aboard numbered 61 people. The ship was commanded by Lieutenant Commander S.G. Campbell, who would have been aware of the Proteus disappearance and the similarities between his ship's mission and that of the lost vessel. The USS Nereus vanished during her voyage to Maine. No communication was received after her departure from St. Thomas. No distress signal indicated problems. No search located any wreckage or debris. The ship and all 61 people aboard disappeared as completely as the USS Proteus had 3 weeks earlier, and as the USS Cyclops had 23 years before that. The Navy declared the Nereus missing on December 31, 1941, as the nation focused on mobilizing for war rather than on solving the mystery of missing auxiliary vessels. The loss of both the USS Proteus and USS Nereus within 3 weeks created alarm among naval authorities and prompted investigation into whether a common cause had destroyed all 3 ships of the Proteus class. The timing of the losses, occurring at the beginning of American involvement in World War II, initially suggested enemy action. German submarines were known to be operating in the Atlantic, and the strategic importance of bauxite ore made the vessels legitimate military targets. However, examination of German naval records after the war revealed no claims of sinking either the Proteus or the Nereus. The identical circumstances of the 3 disappearances suggested that design flaws inherent to the Proteus-class colliers created vulnerabilities that led to catastrophic failure under certain operational conditions. All 3 ships had been carrying dense ore cargoes when they vanished. All 3 were operating as single vessels without escort or nearby support. All 3 disappeared without sending distress signals or leaving debris. All 3 were elderly vessels with decades of service and accumulated structural wear. Naval architects who examined the Proteus-class design after the 1941 losses identified several features that may have contributed to structural weakness. The length-to-beam ratio of 542 feet to 65 feet created a relatively narrow hull that was susceptible to hogging and sagging stresses in seaway conditions. The single smokestack design placed the engine room amidships, creating a concentration of weight that imposed bending moments on the keel structure. The hold configuration, designed for coal cargo, did not include adequate subdivisions to prevent shifting of denser ore cargoes. The coincidence of all 3 losses involving ore cargoes supported theories that cargo characteristics played a crucial role in the disasters. Coal, which the ships were designed to carry, has a specific gravity of approximately 1.0 and fills cargo holds completely when loaded to capacity. Manganese ore and bauxite ore both have specific gravities exceeding 2.5, meaning they occupy only partial hold volume when loaded to weight capacity. This partial loading creates void spaces where cargo can shift during heavy rolling, potentially causing sudden capsizing. Statistical analysis of the 3 losses indicated that the probability of 3 identical ships disappearing by chance was vanishingly small. Maritime actuaries calculated that the odds of losing an entire class of naval vessels to unrelated causes within a 23-year period approached astronomical levels. The pattern strongly suggested that a common vulnerability existed in the ship design, the operational practices, or the interaction between dense cargo and aging hull structure. The investigation into the 1941 losses benefited from improved technology and scientific understanding compared to the 1918 inquiry into the USS Cyclops. Metallurgical analysis of steel samples from other vessels of similar age and construction revealed patterns of fatigue and corrosion that would not have been detected in 1918. Studies of bulk cargo behavior identified mechanisms by which ore could liquefy or shift suddenly under conditions that appeared safe, based on visual inspection. Weather analysis using improved forecasting methods showed that localized severe weather could develop in areas where observations were sparse. The search operations for the USS Proteus and USS Nereus employed more advanced equipment than had been available in 1918, including improved radio, direction-finding systems, and better coordination between surface vessels and aircraft. Despite these advantages, the searches produced the same negative results that had frustrated investigators seeking the USS Cyclops. No wreckage from either the Proteus or the Nereus was ever located. The ocean had swallowed both vessels as completely as it had consumed their sister ship more than 2 decades earlier. The Navy's response to the loss of all 3 Proteus-class colliers included immediate changes to ore transport procedures and accelerated retirement of elderly auxiliary vessels. Remaining colliers that had been adapted to carry ore were subjected to thorough structural inspections, with vessels showing significant deterioration removed from service. New requirements mandated that ore cargoes be loaded in ways that minimized the risk of shifting, including the installation of temporary bulkheads within holds to create smaller compartments. The families of the 58 people lost aboard the USS Proteus and the 61 lost aboard the USS Nereus received official notification that their relatives were presumed dead following the disappearances. The wartime context meant that these losses were classified alongside combat casualties, though the circumstances suggested maritime accidents rather than enemy action. Compensation and survivor benefits were processed through standard Navy channels, with the same uncertainties about exact causes that had affected families of USS Cyclops victims in 1918. Modern analysis of the Proteus-class losses has incorporated advances in naval architecture, materials science, and computer modelling. Simulations of hull stress under various loading conditions have shown that the combination of structural age or cargo weight distribution and moderate sea states could create failure modes that lead to rapid sinking. The simulations support theories that all 3 ships suffered catastrophic structural failure, possibly initiated by cargo shifting or by keel fractures that had developed from decades of cyclic loading. The geographic pattern of the disappearances has attracted attention from researchers examining the Bermuda Triangle phenomenon. All 3 ships vanished in the Western Atlantic, in waters that fall within the boundaries later defined for the Bermuda Triangle. The coincidence has fueled speculation about environmental factors unique to this region that might contribute to ship losses. However, scientific analysis has found no oceanographic or atmospheric characteristics that would explain the pattern of losses beyond the normal hazards faced by any vessels operating in this area. The legacy of the Proteus-class colliers extends beyond the immediate tragedy of 428 lives lost across 3 vessels. The disappearances influenced naval ship design practices, cargo handling procedures, and maritime safety regulations. The complete absence of survivors or wreckage from any of the three ships demonstrated the vulnerability of vessels operating in deep ocean waters far from assistance. The pattern of losses highlighted the dangers of adapting vessels to carry cargoes substantially different from their original design parameters. Attempts to locate the wrecks of the USS Cyclops, USS Proteus, and USS Nereus using modern deep-sea search technology have been unsuccessful. The probable search areas cover thousands of square miles of ocean, with depths exceeding 10,000 feet. The vessels, if they sank intact, would have come to rest on the abyssal plain, where sediment accumulation over decades would obscure their remains. Side-scan sonar surveys of limited portions of the search areas have detected numerous objects on the seafloor, but none have been confirmed as wreckage from the missing colliers. The loss of all three Proteus-class colliers represents the disappearance of an entire class of naval vessels. Combined, 428 people vanished aboard these three ships. The USS Cyclops took 309 souls with her in 1918. The USS Proteus claimed 58 lives in November 1941. The USS Nereus took 61 people in December 1941. Not a single body, piece of wreckage, or personal effect from any of the three vessels was ever recovered. The cause of their disappearances remains officially undetermined.